I think audio and video is clear. Okay. So good evening everyone, and in today's session we'll discuss about questions of power electronics, machines and power system. Okay. So total 31 questions are there, and me and Ashu Sir will discuss these questions. So the first half is for the first half I'll discuss like 15 to 16 questions with you, including the machines and power electronics, and then Ashu Sir will start from that point onward, and then Ashu Sir will take next 5 questions of machine, and then extra 10 questions for power system. Okay, so this way we can complete total 31 questions, and these questions are very important for all of you, so I hope you will enjoy, and let's see. So before starting the session, let's first introduce myself. This is my my introduction. So I teach almost every subject, and now we are studying machines and power electronics. Okay, so there is one more important information for all of you, and that is one mega workshop is there, and this will be on 29th of January for GATE 2024. So if you know your friends, or maybe you know your junior who want to prepare for GATE 2024, please recommend this session to them, and they can register for the mega workshop, and they can enjoy, and they can get the tips from Rakesh Talleja sir. Okay, this is one more important announcement for all of you. We have decided to give you the exam analysis on 5th and 11th of February. So for EC and EE, it will be on 5th, okay, at 1 p.m. and 6 p.m. So you can join us, and you can match your solution, you can match your answers with us, and you can get your all the analysis, entire questions will be discussed in this session. So you can join this session on 5th just after exam. Okay, there is one important point, is All India Open Mega Mock Test is also there for GATE 2023 students, and you can register for that. The link is given in the description below. So for this test you can register in the link. Okay, there is one GATE Super 11 series has already started, okay, for each and every subject. So that will start from 27th of January, and you can also watch this series so that you can get some good score in your subject. Okay, so let's start the session, guys. Let's start. Okay, so this is my first question. Okay, I start with this question. So let me take the pen. So this is the first question, guys. A boost converter has an input voltage of 5 volt. We have a boost converter, input voltage of 5 volt, and an average output voltage of 15 volt. Okay, so it's a boost converter, input voltage is 5 volt and the output voltage is 15 volt. The average load current, it means the output current, is 1 ampere at the switching frequency of 20 kilohertz. The switching frequency of 20 kilohertz. The peak value of the inductor current for L equal to 250 microhenry is given by. We need to calculate the peak value of the inductor current. Tell me, guys, what will be the correct answer? Do it fast. You have 2-3 minutes. I'm giving you 2 to 3 minutes. Okay, and this is a 2-mark question. This is a 2-mark question. So please solve it. This is 2-mark question, and you have to solve it. So do it fast, guys. Do it fast. Let's see how many of you can solve it. Okay, so do it fast. You have 2 to 3 minutes. Do it fast, guys. Do it fast. Let's see how many of you can solve it. I can help you in drawing the diagram of boost converter. Okay. Okay, now we know that the boost converter is like this. We have an inductor, and here we have the switch, and we have the diode, the capacitor and the resistor. Okay, this is my boost converter. I think this is VD and this is V0. Okay, now tell me which option is correct. Do it fast. Tell me which option is correct. Vishwanathan Murli, Agra. Okay. Anyone else? Okay, guys. And those students who have joined it late, please like this session and subscribe our channel. So do like this session because we have to make at least half century of likes. Okay. So please like this session, guys. So tell me what should be the peak value of the inductor current? How to calculate that? First, let's assume that the conduction is continuous because we don't know whether the conduction is continuous or discontinuous. So what we are going to do is we are assuming that the conduction is continuous. Okay, and we know that in continuous conduction, V0 upon Vd has to be 1 over 1 minus d. In boost converter, it has to be 1 over 1 minus d, and it will be equal to V0 is given as 15 and it is given as 5. Input voltage Vd is given as 5, so it will be cancelled with 3. So from here 1 minus d has to be 1 by 3. So d came out to be 2 by 3. So we have calculated d. Okay, we have calculated the value of d for continuous conduction. I have assumed that the conduction is continuous and I have calculated the value of d. Now let's check whether the conduction is continuous or discontinuous. How you are going to check it? During the t on time, during this dt time, dt means t on time, the voltage across the inductor is Vd itself, 5 volt. Okay, the voltage is 5 volt. You can see that this is 5 volt. And during this off period, what is the voltage across inductor? During the off period, when the switch is off, let's call it ground, this side will be Vd, and since the diode is conducting during off period, so this voltage, this is sorted here, and whatever the output voltage is, that voltage will appear here. So you can say that voltage across inductor will be Vd minus V0. Vd minus V0 is 5 minus 10. So 5 minus 10 is minus 5 minus 15. 5 minus 15, that is minus 10. Okay, I hope it is clear. So this is the voltage across inductor. Since we are assuming that the conduction is continuous, so the current will be, so let me draw the current shape. Current will be like this. Okay, current will be like this. Okay, so let me redraw this. So current shape will be like this. Okay, now this is I min, this is I max, and this gap I call delta IL. Now how to calculate this delta IL? And the average value is already given to us. Average value of the current is 1 ampere. This current is average value is given as 1 ampere. So let's call it I naught. Okay. Now what is this delta IL? How to calculate delta IL? Delta IL will be equal to, delta IL means IL max minus IL min. IL max minus IL min is equal to 1 by L integration. The voltage across the inductor is 5 volt during this 0 to dt time. 0 to dt time, the voltage is 5 dt. Okay, this is my delta IL, guys. So it will be 5 by L dt. 5 by L dt. This is my delta IL. Now the peak value will be, what is the peak value? Whatever the average value is, plus delta IL by 2. Okay, so the average value is I naught plus delta IL by 2 will be the peak value. IL peak will be my IL peak. I think this is not correct. Is it correct, guys? Tell me. I think this is not correct. Why? Why it is not correct? Because in calculating this I naught is not the output current. This is the IL average. This is inductor average voltage, not the output average. Output average current is given as 1 ampere. So we can calculate the input average current, IL average or ID. IL average or ID. Okay. How to calculate this IL average or ID? How to calculate that? Using this relation. We know that V0 upon Vd is 1 over 1 minus d. That is equal to IL average upon I naught. Okay. So from here you can calculate IL average. And IL average came out to be I naught into 1 over 1 minus d. 1 over 1 minus d is 3. Okay. 3 times of I naught. So it came out to be 3 ampere. Is it fine, guys? I naught value is given as 1 ampere. So we have calculated the average value of inductor current. So this is average value of inductor current and it came out to be 3 ampere. So IL peak will be equal to this average value plus delta IL by 2. Okay, so this I naught should not be there. In place of I naught, what should I have? IL average plus delta IL by 2. This is the peak value, guys. This is the peak value. Okay, and IL min, what is IL min? IL min is IL average minus delta IL by 2. Okay, this is my IL min. Now how to check whether the conduction is continuous or discontinuous? Using this IL min. If this IL min came out to be positive, then we call that the conduction is continuous. If this IL min came out to be negative, then the conduction is discontinuous. So we have started by assuming that the conduction is continuous. Okay, we have started by assuming that the conduction is continuous. We have calculated the value of D, and then we have calculated the IL average, the input side average current, because output side average current is given. It is 1 ampere. So what we have done is we have calculated the input side average current. So input side average current came out to be 3 ampere. Okay. So now we need to calculate IL peak value of inductor current. Obviously it has to be greater than 3 because this average current is 3 ampere. So it has to be greater than 3. Only B option is there, which is greater than 3. So either B option is correct, or I mean we have to check. We have to check whether the conduction is continuous or discontinuous, because entire analysis is for continuous conduction. How to check whether the conduction is continuous or not? By using this IL min current. Now let's calculate this IL min. IL average came out to be 3 ampere. IL average came out to be 3 ampere. From this relation you can see that IL average came out to be I naught into 3, that is 3 ampere, minus 1 by 2 into delta IL by 2, 5 by L. L value is 250 microhenry, 250 into 10 square minus 6, okay, into D. D value is, what is D? D value is 2 by 3. And what is T? What is the frequency? It's 20 kilohertz. So the time period is 1 over 20 kilohertz, 20 into 10 is to power 3. Is it fine, guys? So we have to calculate this value, and please tell me whether it is positive or negative. What is this value, guys? Whether it is positive or negative. If it came out to be negative, then the conduction is discontinuous. If it came out to be positive, it means the conduction is continuous and the peak current will be this. Okay, so it's easy peasy. So tell me, guys, tell me what is this value? What is this value? Please tell me whether it is positive or negative. So using this calculation, we can check whether the conduction is continuous. If the conduction is continuous, then IL peak is this. If the conduction is discontinuous, then this analysis is wrong. This D is not wrong. You cannot apply this formula. Okay, so you have to be careful. Now tell me, what is this value? This value came out to be 2.66. Okay, 2.66 as per Viswanathan. Okay, thank you, Viswanathan. So this came out to be positive. If it is positive, 2.61. If it is positive, it means the conduction is continuous. If the conduction is continuous, this is correct. This D is correct. So IL peak came out to be this value. Now how to calculate this? IL peak is equal to IL average, which is 3 plus delta IL by 2. So it will be more than 3. Answer is Bombay. Is it fine, guys? Is it fine? So this way you can solve this question. First you have to check whether the conduction is continuous or discontinuous. How to check it? Using this IL peak value. Using this IL peak value, you can calculate whether the conduction is continuous or discontinuous. If the conduction is continuous, then only you can calculate the IL peak. I think it's clear to everyone. Tell me, everyone. So answer is Bombay. So it's a 2-mark question. I hope you understood it. Let's come to the next question. Let's come to the next question. Please solve this question, guys. A single phase full bridge converter with a freewheeling diode feeds an inductive load. Inductive load means RL load. It's not pure inductive, okay? It's an RL load. So we have a single phase full bridge converter with a freewheeling diode feeds an inductive load. The load resistance is ripple free. The load resistance is ripple free DC current. Load current or load inductance. Wait a minute, let me check the original file because I think there is a correction in this question. So just wait, just give me 1 minute so that I can check the original file and rectify it. Okay. A single phase full bridge rectifier with a freewheeling diode feeds an inductive load. The load resistance is 15.53 ohm. The load resistance is, please add 1 point here. The load resistance is 15.53 ohm. 15.53 ohm. The load resistance is 15.53 ohm. It has large inductance providing constant and ripple free DC current. Okay, it has large inductance and large inductance. It has large inductance. Okay, the load resistance is 15.53 ohm and large inductance providing constant and ripple free DC current. Providing ripple free DC current. Okay, so this line is included, guys. This was missing. The load resistance is 15.53 and large inductance providing the ripple free DC current. The input to the converter is from an ideal 230 volt 50 hertz single phase source. So this is AC supply to the converter. For the firing delay angle of 60 degree, the average value of diode current, it means the freewheeling diode current. So let's first draw the diagram. So the diagram is like this. We have a single phase full converter. Okay, we have a single phase full converter, and here we have connected with a AC source. Now we have a freewheeling diode and we have RL load. Okay, so this is the circuit we have. T1, T2, T3 and T4. Now alpha is given as 60 degree. What I need to do is, resistance value is given as 15.53. It is given that current is ripple free. It means this current you can take it as constant. Okay, now what I need to do is average value of the diode current. I need to calculate the average value of the diode current. How to calculate the average value? Do it fast, guys. Do it fast. Let's see how many of you can solve it. Do it fast. I have drawn the diagram, circuit diagram for you. Okay, do it fast. Let's see how many of you can solve it. So it's very simple. You can replace this load with a constant current source. No problem. Okay, you can replace this load with a constant current source. And what will be the value of the constant current source? I'll tell you, but first you try this question, because this is again a very good question and 2-mark question is this. Okay, this is again a 2-mark question. Do it fast, guys. Do it fast. Let's see how many of you can solve it. This is again 2-mark question. Do it, guys. Do it fast. Do it fast, everyone. Let's see how many of you can solve it. Do it fast. Ram A. Okay. Anyone else? Subham Sripal, Delhi. Okay. Anyone else? Tell me. Anyone else? Tell me, guys. What should be the correct answer? Do it fast. It's very simple. This question is very simple. Just draw the waveshape without freewheeling diode and then with freewheeling diode. Okay. So let me help you. This is my supply voltage. Okay, this is my supply voltage and this peak value is 230 root 2. Okay, alpha is 60, so this is pi plus alpha. Now if you draw the wave shape, the output voltage wave shape, we know that the current is continuous, current is, let's say, constant, I naught. So from alpha to pi, T1 T2 will conduct and the output voltage will be same as the supply voltage. Okay, and then from pi to pi plus alpha, freewheeling diode will conduct. Pi to pi plus alpha, freewheeling diode will conduct, so the output voltage will remain 0, because if there is a freewheeling diode, output voltage cannot be negative. If there is no freewheeling diode, then this voltage has to go negative. But since we know that freewheeling diode is there, so output voltage has to be 0 after pi. So from pi to pi plus alpha, freewheeling diode will conduct, and then from pi plus alpha to 2 pi again, output voltage will be opposite of the supply voltage, because T3 T4 are conducting, and then 0. So this will be my output voltage waveshape. I hope it is clear to everyone. Now can you calculate the average value of this output voltage? Yes, the period is pi. So the average value of the output voltage is 1 over pi from alpha to pi Vm sin omega t d omega t. Okay, this is my average value. So it will be Vm by pi. Integration of sine is minus cos, upper limit minus lower limit is 1 plus cos alpha. This is my average output voltage, V naught T average. Now this V naught T average divided by the resistance value, you will get the average output current. It means you will get this I naught, this constant current, this average current value you can calculate from this average output voltage. Now tell me, what is I naught? I naught will be equal to Vm by pi 1 plus cos alpha divided by the resistance value R. Okay. Now what is the value of Vm? Vm value is 230 root 2. Vm value is 230 root 2. So tell me guys, what is the average value of this current? R is 15.53 pi, okay, and into 1 plus cos 60. 1 plus cos 60. Alpha is 60, na? So we have calculated the average value of the current. Now tell me, what is this average value? Tell me guys, Viswanathan Murli, tell me, what is this? Is it 10? Is this value 10? Tell me guys. Please calculate this if you have the calculator. Please calculate this if you have the calculator. Is it 10 or something else? Viswanathan Murli is saying 10. Tell me guys whether it is 10 or something else. Do it fast. Okay, so it's 10. So we found that the constant current is 10 ampere. But we need to calculate the average value of the diode current. We know that the diode is conducting only during this alpha range. So if I plot this freewheeling diode current, I freewheeling, then from pi to pi plus alpha, this 10 ampere will flow through the freewheeling diode. And then from 2 pi to 2 pi plus alpha, again freewheeling diode is conducting and the current will be 10 ampere. You can see that. So now you can see that the freewheeling diode is conducting only for alpha range and the period is pi. After pi it is repeating, you can see that. Pi point will repeat at 2 pi. So the period is pi and this length is alpha. Now we need to calculate the average value. How to calculate the average value? Average is area under one period divided by the time period. So time period is pi radian and this area will be 10 into, this height is 10, this length is pi minus, this length is pi plus alpha minus pi, that is alpha. It means pi by 3, okay. So multiply by pi by 3. Is it clear guys? This pi is cancelled, 10 by 3 is the average current through the diode. So you don't need to remember any formula. You don't need to remember any formula. Directly you can say 10 by 3. 10 by 3 means 3.33. Answer is Delhi. Is it fine guys? Answer is Delhi. You can check it. I hope it is clear to everyone. Tell me everyone. Can I proceed to the next question? Can I proceed to the next question? Tell me. So answer is 3.33. Let's come to the next question guys. So the next question is, a single phase full bridge voltage source inverter is operating in 180 degrees operation mode with the source voltage 100 0 100. Okay, it means the voltage is varying, either it is 100 or you can take it 0. I mean, this is, I think this is the output voltage. Okay, the phase angle between the pole voltages is 45 degree. The RMS value of the output voltage between the two poles at the fundamental frequency is. Okay, now look, we have this inverter. Let me tell you what is the statement. If the statement is not clear to all of you, let me tell you guys. So here you have 100 volt. Here you have 100 volt. So let's call it ground. So this will be 100 volt. And this point is pole P1, this point is pole P2. So he is saying that this leg is working for 180 degree square operation mode. This leg is also working for 180 degree square mode. Okay, and the phase angle between the pole voltages is 45 degree. It means this voltage and this voltage have the phase angle of 45 degree lag. It means if you want to plot this P1 voltage, now tell me what is the P1 voltage? VP1. If you connect this switch, then this voltage will be 100 volt. If you connect this switch, it will be 0 volt. Okay, so you can say that, because this is not, I mean, this is not clear, na? How the voltage is varying. I am assuming that 100 to 0 and then again 100. He wants to say 100 and then 0 and then 100. So it is varying like this. The pole voltage is varying like this. So if the pole is, if this switch is connected and this switch is connected, so let me draw the, not this switch, okay, not this switch. We have to take this switch off, okay, because we are using this separately, na? Okay, guys. So what we are using is, first let's look at this leg. When I connect this, first I connect this for 180 degree. For 180 degree, this pole is connected with the upper point, so the voltage is 100 volt. And then for the next 180, it is 0, okay, and then it is 100 again. So this is the pole voltage P1. Now what is the pole voltage P2? The P2 will again be for 180 degree conduction mode. It is also for 180 degree conduction mode, but the P2 voltage is 45 degree lagging. So what we can do is, if we want to plot the P2 voltage, it will be 45 degree lagging, pi by 4 lagging. So it will start like this, and then for next 180 degree, it will be like this. So if it is 45, then this will be 225. Is it fine? And then for next 180 degree, it will be off, and then again it will start like this. I hope it is clear. So I have delayed it by 45 degree. The conduction mode for this pole is again 45 degree. 180 degree. You can see that for 180 degree, this point has the 100 volt, and then for next 180 degree, this is off. This point is on. Okay, I hope it is clear. I hope it is clear. So we have drawn the voltage VP1 and VP2 for 180 degree conduction mode. Okay, and the VP2 is 45 degree lagging. Now we want to calculate this difference V0. So if you can plot this V0. Now tell me guys, how to plot this V0? From 0 to pi by 4, you can see that. From 0 to pi by 4, you can see this is 100, this is 0. So if you take the difference, you'll get 100 volt. You'll get 100 volt. Okay. Now from pi by 4 to pi by 4 to pi by 4 to pi, it will be 0, because this is 100, this is 100. So the output voltage will be 0. Now from pi by 4 to 5 pi by 4, pi by 4 to 5 pi by 4, you can see that this voltage is 0 and this voltage is 100. So we can take the difference, and the difference will be minus 100 volt. Is it fine, guys? It will be minus 100. Okay. Now the next is again 5 pi by 4 to 2 pi. 5 pi by 4 to 2 pi. Again voltage is 0. Why? Because 5 pi by 4 to 2 pi, it is 0, and this is also 0. Now from 2 pi to this point is 2 pi plus pi by 4. So it will be 9 pi by 4. From 2 pi to 9 pi by 4, it will be again 100. So this will be my output voltage. Is it clear, guys? This will be my output voltage. Okay. You can see that this is the output voltage we have. I hope it is clear. And you can see that the period is 2 pi. This 0 will appear at 2 pi again. Okay. So this is my output voltage. Now the question is, I need to calculate the RMS value of the output voltage between two pole at the fundamental frequency. We need to calculate the RMS value of the fundamental component of this wave. Now how to calculate the RMS value? To calculate the RMS value, what we can do is, we can use the quarter wave symmetry. But the problem is, this signal is not, it does not contain quarter wave symmetry. Okay, you can see that this is neither odd nor even, because if you plot on this side, this will be like this. Okay, so you can see that this is not a odd signal, and it does not contain quarter wave symmetry. Now how to calculate the fundamental component? It's very simple. The amplitude of the fundamental component does not depend on the origin. So you can shift the origin. You can shift the origin such that the signal become odd, and it contain odd half wave symmetry, so that odd plus odd half wave symmetry become quarter wave symmetry. Because if the signal contain quarter wave symmetry, then it is easy to calculate its fundamental component. I hope it is clear. So what we can do is, let me tell you guys, what you can do is, you can shift the origin. Don't assume that the origin is here. Let's assume that the origin is here, so that it becomes symmetric. I hope it is clear. Now you can see that the wave is symmetric. Okay. Now you can see that the wave is symmetric, and this point will become, I mean, with respect to this point, with this, if you call it origin, then this point will become pi by 2, okay, and this point, somewhere this point, okay, somewhere this point will become pi. Okay guys, if you assume that this is the origin, if this is the origin, then this wave will become symmetric, and you can see that this is one period, this is 1/2 period pi, and this is 2 pi, okay, this point is 2 pi. So every point is shifted away, no? Every point is shifted in forward direction. Now you can see that this wave contain odd symmetry, and itself is odd, it contain odd half wave symmetry also. So overall it will become quarter wave symmetric. Overall it become quarter wave symmetric. Now you can calculate the peak value of the fundamental component. Using the quarter wave symmetry, you can use the peak value of the fundamental component. Now what is the peak value of the fundamental component? It's very simple. This is my pi by 2 point now. So if it is pi by 2, this will be equal to pi by 2 minus pi by 8, because this entire length is pi by 4. So this will be pi by 2 minus pi by 8. Pi by 2 minus pi by 8, okay. Now if you want to calculate the peak value of the fundamental component, that will be equal to 4 by pi integration, 4 by pi integration from this point to pi by 2. And what is this point? Pi by 2 minus pi by 8. You take this LCM as 8, so it will be 3 pi by 8, okay. So this point is 3 pi by 8, so you can integrate from 3 pi by 8 to pi by 2, and the peak value is 100 sine of omega t d omega t, okay. This is the peak value of the fundamental component. Now you should know how to apply the quarter wave symmetry. Those students who don't know this quarter wave symmetry, please revise it, okay. So now you can take this 100 common, so 400 by pi, integration of sine is minus cos, upper limit is 0 and the lower limit is cos 3 pi by 8. This is the peak value, guys. This is the peak value of the fundamental output voltage. We require RMS value. RMS value of the output voltage. So you just divide it with √2. Is it fine, guys? This is my answer. You can calculate this value and this will be the answer. Is it fine? Now many of you don't know about the RMS value, or the how to calculate this quarter waves, how to apply this quarter wave symmetry. So please revise it, otherwise it will be difficult for you. Okay, let's come to the next question, guys. You can calculate this value and you will get the answer. Okay, whatever answer is, I don't know, is it 90 volt? If it is 90, it's fine, but you have to be careful how to apply the quarter wave symmetry condition. You don't need to remember anything. If you know the analysis part, everything is easy. So it came out to be 90 volt. Okay, thank you. It came out to be 90. I don't know the calculation. Ram and Subham Sripal is saying 90. So let's take it 90 volt. Let's come to the next question, guys. So the next question is, a line commutated inverter transfer energy into 440 volt 50 hertz 3-phase supply from a battery of 500 volt. Okay. So the question is saying that we have a battery of 500 volt and it is supplying energy to the source side. We have the source side, okay. Okay, the battery is linked to the converter through a large filter choke of resistance. So it is connected with a filter choke of resistance 12.4 and this L is very large, okay. So the battery is connected like this. It is desired to transfer 5 kilowatt power into the system. So this battery is delivering the power to 5 kilowatt. And here you have 3-phase converter. Here you have 3-phase converter. Okay, and it is working in the mode of inverter. I mean, it's working like inverter. So it will work like inverter only if you reverse the polarity of this voltage source. Okay, so what you do is you reverse the polarity of this voltage source. Okay, you reverse the polarity of this voltage source so that it can work for, so that it can deliver the power. Okay, so it is 500 volt. So and it is given that the choke is large, the filter choke of the resistance 12.4 and this L is large. It is given that the L is large. You can see that large filter choke is given, large filter choke. It means L is large and the resistance is 12.4 and it is delivering the power which is equal to 5 kilowatt. It means from this side the current the current is going like this, and how much current? 5 kilowatt. 5 into 10 is to power 3 watt. This much of power is supplied from this side. So now it is desired to transfer 5 kilowatt power into the system. On this side, 5 kilowatt power is supplied. The firing angle at which the inverter to be operated is, we need to calculate what is the firing angle. We need to calculate what is the firing angle alpha. What is the firing angle alpha? So we are assuming that the conduction is continuous and it's a three-phase converter. So obviously this source is not a single source, there are three sources. Okay. Now in three-phase full converter, if you remember, the average output voltage is 3 root 3 Vm by pi cos alpha. Okay. And it has to be equal to, tell me guys, it has to be equal to, if you calculate the average output voltage, the current is going like this and the voltage has opposite polarity. And so this has the polarity like this, okay, because current is going down. Average voltage across inductor will be 0, we know that. So the total average output voltage has to be equal to 12.4 I naught minus 500, okay, because if you go upward, this is negative and this is positive, okay. So this will be my the voltage equation. This is the total average output voltage. This must be equal to minus 500 plus 12.4 into I naught. Now if somehow we can calculate this I naught value, we can put it here and calculate the value of alpha. Now how to calculate the value of I naught, the average current? It is given that 5 kilowatt power is transferred into the system. It means from this side, the total power delivered is 5 kilowatt. We know that the voltage across this is 3 root 3 Vm by pi cos alpha. This is the average voltage into the average current. That has to be equal to 5,000. Okay, because the total average voltage, entire average voltage across this is 3 root 3 Vm by pi cos alpha, multiply by this current I naught. This will be the power delivered on this side and it has to be 5,000. So from here you can see that I can calculate this value. Or you can replace I naught with this value. Okay, let's calculate the value of this because this is very, so 3 root 3 Vm by pi cos alpha is equal to 5,000 upon I naught. I hope it is clear. Okay guys, 3 root 3 Vm by pi cos alpha is equal to 5,000 upon I naught. So what you can do is, in place of this, you can write it like this: 5,000 upon I naught is equal to 12.4 I naught minus 500. Now you can calculate I naught from here. Okay, so this will be a quadratic equation. So it will be 5,000 is equal to 12.4 I naught square minus 500 I naught is equal to, okay. So this is the equation. Now first calculate I naught, put the I naught value here. And the value of Vm, what is Vm? This is RMS line voltage. This is the line voltage, guys. So the phase voltage will be 440 root 2 divided by root 3. Okay, why I have multiplied with root 2? Because this is the RMS value. So the peak value of the line voltage is 440 root 2. This is the peak value of the line voltage. And the peak value of the phase voltage is divided by root 3. Okay, this is my Vm. I hope you understood it. Okay, this is my Vm. So Vm can be calculated from this line voltage, because on three-phase side, this voltage is line voltage and the RMS value of the line voltage. So the peak value of the line voltage is this, and this Vm is the maximum value of phase voltage. So you just divide it with root 3, you will get the maximum value of the phase voltage. I hope it is clear. Okay, so we can put the value of Vm and we can calculate the value of alpha if you know this I naught value. Now I naught can be calculated from this equation. Can you tell me what is the value of I naught? Can you tell me what is the value of I naught, guys? From this relation, can you calculate the value of I naught? Tell me, guys. So it will be 12.4 I naught square minus 500 I naught minus 5,000 is equal to 0. So this is the equation I have. This is the equation I have, and now I can calculate the value of I naught using this value of I naught, we can calculate the value of alpha. Please calculate what is I naught. I naught came out to be 40.32. Okay, 40.32 as per Ram. Okay, 40.32. Is it clear, guys? I naught came out to be 40.32. So now what you need to do is you put the value of I naught here. You put the value of I naught here and put the value of Vm and calculate the value of alpha. So cos alpha. So now you can see that cos alpha is equal to 5000 divided by I naught. I naught is 40.32 if your calculation is correct. 40.32 divided by 3 root 3. In the numerator we have pi. This 3 root 3 came in the denominator and the pi came out to be in the numerator, divided by Vm. So I have to take this in the denominator. So it will be root 3 divided by 440 root 2. Is it clear, guys? Is it clear? Okay. So we can put the value and calculate the value of alpha. So root 3 is cancelled. Okay, root 3 is cancelled. Now calculate this cos alpha value. Tell me, guys, calculate this cos alpha value. Calculate this cos alpha value. Now tell me, what is this cos alpha value? What is this cos alpha value? Tell me, guys. Wait a minute. I think, wait a minute. This voltage is of this polarity. I think I have made a mistake. Okay. I have made a mistake. Where did I made a mistake? Okay. Where did I made a mistake? I made a mistake of negative sign. I forgot to put a negative sign. Okay. It should be 500 minus this, because this voltage, this output voltage is of this polarity. It has to be of this polarity, then only it will deliver the power, na? And this polarity voltage has to be 500 minus this voltage. So there should be minus here. This should be the correct equation. Okay. Because this voltage is of this polarity, okay? This voltage is of this polarity. I hope it is clear. Now, in place of this value, you have 5000 upon I naught, okay? So what I have done is, I have put the 5000 upon I naught value, minus here, plus here, okay? Is it fine, guys? So you have to put it like this. And then you have to calculate the value of I naught. Let me do it from the beginning, okay? Let me do it from the beginning. Okay, so wait a minute, let me do it from the beginning. So it's a simple question, guys, nothing to worry. It's a very simple question, only the plus minus you have to be careful, okay? Don't make mistake in taking plus and minus that I have done in this question. So let's start it again. So this is the load side and it is delivering the power back to the source. So you can see that the average output voltage is 3 root 3 Vm by pi cos alpha. This is my average output voltage, and it will deliver the power back to the source only if this voltage came out to be negative. This voltage has to be negative value, because the polarity should be like this. This should be plus and this should be minus. It means the alpha should be greater than 90. Then only it will deliver the power. So it has to be negative value, okay? This has to be of, I mean, this, if you are looking V naught T of this polarity, it will be positive. But if you are looking V naught T of this polarity, then this value will be negative. And it has to be equal to, what is this value, guys? It has to be equal to minus 500 plus 12.4 I naught. I think it is clear. Okay, I think it is clear. So I told you that you have to do it like this, minus 500 plus 12.4 I naught. I think previously we have done it correctly. Anyway, so this is the power, this is the voltage equation, because I have taken this polarity of the output voltage. So this polarity of the output voltage will come negative. This is negative value. Okay, and it will be minus 500 plus 12.4 I naught. That is correct. This is the first equation. Now the second equation is, this is delivering the power. So the current is on this side, current is going in this side, and this voltage is of this polarity. So 3 root 3 Vm by pi cos alpha of this polarity into I naught is the power delivered from the source side. Actually, this is power absorbed. Why? Because this current is entering in the positive side. So this is power absorbed. So it has to be equal to minus 5000. It has to be equal to minus 5000 because this is the power absorbed. This is the power absorbed, and actually the load is delivering the power. Since it is absorbing, since the current is entering in the positive sign, that's why the product is power absorbed, and actually it is delivering. It is delivering 5000 power. So the power absorbed is minus 5000. Okay, I hope it is clear. So now you can calculate I naught from here. So I naught came out to be minus 5000 divided by 3 root 3 Vm by pi cos alpha. I hope it is clear now. Now this is correct. This time it is correct. So we have calculated the value of I naught. Okay, I naught is this. Or you can also write it there. You can calculate this value. So this value is equal to 3 root 3 Vm by pi cos alpha is equal to minus 5000 upon I naught. Okay, and you can put this value in this equation. So if we put this value in this equation, it will be minus 5000 upon I naught is equal to minus 500 plus 12.4 I naught. Is it clear, guys? Now you can cross multiply. So it will become 12.4 I naught square minus 500 I naught plus 5000, that is equal to 0. Okay, so we got this relation. We got this relation. Now please calculate I naught value. Now tell me the I naught value. This is correct now. This time it's correct. This time it's correct. Okay, now calculate the value of I naught. What is the I naught value, guys? If you have the calculator, please solve it. Now this time it is correct. Don't make such mistake, because this into this voltage is of this polarity. Upper point is plus and lower point is minus, and the current is going on this side. So it is the power absorbed, and this power is delivered power. So absorbed power is minus 5000. Is it fine? So now you have to put it minus 5000 here, and then you can calculate. You can calculate this value in terms of I naught and put it here. So you can calculate the value of I naught. What is the value of I naught, guys? If you have the calculator, please calculate it for me. Do it fast. Let me see whether I have the calculator or not. If I have the calculator, okay, I have the calculator. Okay. So now I can do it fast. I have the calculator. So if you want to solve this, you go to the equation mode, okay, and try to solve it. 12.4, then minus 500, and then 5000. Okay, so it came out to be 21.96. 21.96. This is my I naught value, and there is one more equation, that is 18.35. So there are two current values. Okay, there are two current values which are satisfying this. Okay, so there are two possible answers. There are two possible answers. Okay, now if you got this current value, you can put it here. You can put it here and calculate the value of alpha. What is Vm? Vm is the maximum value of the phase voltage. How to calculate the maximum value? This is the line voltage RMS value. If it is the line voltage RMS value, then the line voltage max value will be 440 root 2. This is the line voltage max value. Now we require phase voltage max value. So divided by root 3 will be my Vm. Okay. So we can calculate the Vm like this. We can put the Vm here and the value of I naught. There are two options. So you can put these two values and you will get alpha. So alpha will be b square minus 4ac came out to be negative. No, I don't think so. I have calculated it. Wait a minute. Let me see it again. 5 equation, and then okay, this is 12.4 and that is equal to minus 500 and then 5000. Okay, it came out to be positive 21.96 and 18.36. please check your. Okay, so there are two current values. Put these two current value here and calculate the value of alpha. I think it's easy peasy. Now you can easily solve it. So I don't want to do in the calculation part, and you can solve this question easily, and you can calculate the value of alpha. There will be two options. Two answers can be correct. Okay, now let's come to the next question, guys. Now this is the question on your screen. A three-phase full converter feeds power to a resistive load of 10 ohm. So we have a resistive load and a three-phase full wave converter is there. Firing angle is 45 degree. Okay, the load takes 1 kilowatt. Find the magnitude of the line voltage. Okay, find the magnitude of the line voltage. Do it fast, guys. Do it fast. Again, it's a 2-mark question. It's a 2-mark question. It's a 2-mark question. Do it fast. Do it fast, guys. Do it fast. We are actually very slow because the questions are lengthy. Because I have selected all the questions of 2 marks. I don't know why. But anyway, solve this question. It's a simple question. Now, first of all, tell me, for 45 degree, whether the conduction will be continuous or discontinuous in R load. Tell me, guys. For 45 degree, conduction will be continuous or discontinuous. Tell me, guys. Look, we have a 3-phase. So let me draw the 3-phase output voltage. The wave shape of 3-phase output voltage will be like this. Let me draw the wave shape of 3-phase output voltage. So it will be like this. Okay, this is the wave shape of 3-phase output voltage for alpha equal to 0. For alpha equal to 0, and this is my origin line. Okay, now we know that alpha is 45 degree. So alpha is measured from this. Okay, if alpha is 45 degree, we know that at alpha equal to 60 degree, the conduction is just continuous. This is alpha equal to 60 degree. For alpha equal to 60 degree, for R load, the conduction is just continuous. You can see that. Okay, for alpha equal to 60, because alpha is measured from this point now. For alpha equal to 60 degree, the conduction is just continuous. If alpha is greater than 60, it will be discontinuous. If alpha is less than 60, it will be continuous. So conduction is continuous because alpha is 45 degree. Okay, since alpha is 45 degree, you can see that alpha is 45 degree. For alpha equal to 60 degree, if you take alpha here, alpha is measured from this instant, remember. If alpha is 60 degree, then the conduction will start from here, and the next 60, the first thyristor will be fired here, and the next will be fired here. So up to this point, this will be VAB and then VAC, okay? For alpha equal to 60 degree. At alpha equal to 60 degree, conduction will be just continuous. Alpha less than 60 degree, conduction will be continuous. And alpha greater than 60 degree, discontinuous. Since alpha is 45 degree, so the conduction is continuous. It's less than 60 degrees. So it's continuous. And in continuous conduction, the output average voltage will be 3 root 3 Vm by pi cos alpha. This is my average output voltage expression in continuous conduction, if you remember. Okay. And it is given that the load is purely resistive and load takes 1 kilowatt power. So now you can calculate the average, you can calculate the RMS current. Because from the power, you can calculate the RMS current. Because we know that I naught T RMS square into R, that is equal to power 1000. Now I naught T RMS came out to be 1000 divided by resistance value 10 and take the root of this. So it will be 10 ampere. So RMS current, output RMS current came out to be 10 ampere. Okay. This is not the average value, remember. So you don't need to calculate the average part. You need to calculate the RMS part. So the RMS value of the output current is 10 ampere. You have to equate the RMS value to 10 ampere and then you can calculate the line voltage. How to calculate the line voltage? First, let's look at the RMS value of the output current. What is the RMS value of the output current? For that, you just plot the wave shape for alpha equal to 45 degree. Let's say the alpha is 45 degree. So let me redraw the voltage. So alpha equal to 40. At this point, alpha is 0. At this point, alpha is 30. At this point, alpha is 45 degree. Okay. From this point to this point. So the output voltage will be like this. In the orange color, you can see that. This is my output voltage, and the output current shape will also be like this. Okay. So I hope you can understand this. Okay. This is my voltage wave shape, the orange color for alpha equal to 45 degree. For alpha equal to 45 degree, this is my voltage wave shape. So you can see that the voltage is continuous. I mean, there is no zero gap. So the current will also be continuous. Now, what you can do is, now you can calculate the RMS value of this current. How to calculate the RMS value? The period is pi by 3. So pi by 3 integration. Now tell me, from which point to which point you have to integrate it? This point is, this length is alpha, and this point is pi by 6. So pi by 6 plus alpha pi by 6 plus alpha to pi by 2 plus alpha. Just add 60 to it. It will be pi by 2 plus alpha. And the equation is VAB. VAB is root 3 Vm sine of omega t. This is my equation of the voltage, and you take the sine omega t plus 30. Okay, this is my VAB. You take the square of this. Okay, you take the square of this d omega t and take the root. So this is my RMS value of the voltage, output voltage. This is the RMS value of the output voltage. So what you can do is you can take these terms outside. So you will get root of. So we have calculated the RMS value of the output voltage for alpha equal to 45 degrees. So put the alpha value, no? Put the alpha value, or you can put it later. So what you can do is you can take this out. So root 3 square is 3 and it will cancel with this. And Vm will come out. Vm will come out. Vm. Inside it is, this should be 1 upon pi by 3. Wait a minute. You cannot cancel it. Okay. What you can do is, wait a minute, let me write it. Okay. So it will be from pi by 6 plus alpha to pi by 6 root 3 Vm sine of omega t plus alpha. You have to take the square of this. You have to take the square of this, divide by the period, and the period is pi by 3. So it will be like this. Is it fine, guys? So now if you solve it, then it will be root 3 square is 3, and here you have 3. So 3 Vm will come out from the root. 3 Vm will come out inside the root sign. It will be from pi by 6 to pi by 2 plus 6 alpha, and it will be sine square omega t plus 30 degree. You have to solve it. Okay, guys, this is my RMS voltage. Divide by the resistance value, you will get the RMS current, and RMS current came out to be 10 ampere. So from here you can calculate the value of Vm. I hope it is clear to everyone. We can calculate the value of maximum value of the phase voltage. This will be the maximum value of the phase voltage. Is it clear, guys? From this relation you can calculate the maximum value of the phase voltage. Once you get the maximum value of the phase voltage, multiply by root 3. This is the maximum value of the line voltage. Okay, this is this way you can get the maximum value of the line voltage, and this is required. Okay, we need to calculate the magnitude of the line voltage. Magnitude means the maximum value we need to calculate. So this will be root 3 Vm. So Vm can be calculated from here because alpha is known to us. Only thing is we have to integrate it, and that's a lengthy process. Okay, so you can solve it and you'll get the answer. I hope you can solve it. So it's a lengthy process. Let me tell you the answer because I have already solved this question. No? So that's why I can tell you the answer. Wait a minute so that I can tell you. For the last question, for this question, the alpha should be, one option is 144.96. Okay. And for this question, let me tell you guys, it came out to be 100 root 2. Okay. It came out to be 100 root 2. V line max. It came out to be 100 root 2. Please check it. Okay. Please check it. It's very simple question. Only the calculation part is a bit lengthy. Otherwise, nothing lengthy. Okay. Otherwise, no. It's simple. Okay. I hope it is clear to everyone. First, we have calculated output RMS current. Now, how to calculate this output RMS current? First, we have to calculate the RMS voltage. RMS voltage. Now, how to calculate the RMS voltage? The period is pi by 6, 60 degree period. So period is pi by 3. So 1 upon pi by 3. Integration from 30 plus alpha. 30 plus alpha is pi by 6 plus alpha to this point. This point is 90 plus alpha. You just add 60 to it. So it will become 90 plus alpha. And this equation is VAB. So VAB is root 3 Vm sine of omega t plus 30. Take the square of this d omega t. You can integrate it. You will get the RMS value of the output voltage. Divide by the resistance, you will get the RMS value of the output current. It came out to be 10. And from here you can calculate the value of Vm. Now Vm is the maximum value of the phase voltage. So you just multiply it with root 3. You will get the line voltage maximum value. Is it fine, guys? Can't we use 3 Vm? Yes, you can use 3 Vm. No problem. You can write this average voltage as 3 VML by pi cos alpha. This is also correct. but we don't require this average value. We don't require the average value because RMS current is there. That's why we require RMS value of the output voltage. That's why we need to take the square of this. Okay, I hope it is clear. Let's come to the next question, guys. So do this question. Tell me what should be the answer for this question. Tell me what should be the answer for this question. It's a very good question again. Okay, do it, guys. Now you can solve this question. Please solve it. Answer has to be 100 root 2. Okay, this 100 root 2 is provided to me. Now you can check it your own and calculate the value of this VL max. Please check your calculation, Viswanathan. Check your calculation. Let's come to the next question, guys. Let's come to the next question. A class C commutation circuit is shown in the figure. So we have a class C commutation circuit. This is 100 ohm. This is also 100 ohm, T1, T2, and this is capacitor. This is again 100 volt. Now the turn of time for the SCR is 50 microsecond and a safety margin of 2. If you are taking safety margin of 2, it means the circuit turn of time has to be equal to 100 microsecond. Okay, so from here we can calculate the circuit turn of time. Okay, so the circuit turn of time came out to be 100 microsecond. From this idea, I mean the SCR turn of time is 50 and the safety factor margin of 2. So it means the circuit turn of time has to be 100 microsecond. We have calculated this. The minimum value of the capacitor to be provided for the proper commutation. We need to calculate the minimum value of the capacitor. What should be the minimum value of the capacitor? Now how to calculate the minimum value of the capacitor? It's very simple. What you can do is you can calculate the circuit turn of time and equate it to 100 microsecond and calculate the value. See, it's simple. Okay, now how to check it? That can be checked with the help of VT1 or VT2. Okay, because using this voltage or this voltage you can check what is the circuit turn of time for thyristor T1. Now how to plot this wave shape? How to plot this wave shape? It's very simple. Let's try to plot it. Let's assume that the capacitor is initially uncharged. If the capacitor is initially uncharged and you are firing this thyristor T1, if you are firing this thyristor T1, how much current will flow? Tell me, guys, how much current will flow? And the voltage across T1, I need to check it. Voltage across T1 and the current IT1. So you can see that if you are going to fire this, it will be sorted here. So the current will be 1 ampere from this side. Okay, so this current will be 1 plus this current will be constant 1 ampere, and there will be one more current via this. There will be one more current via this. Is it fine? And that current will be equal to, initially capacitor will behave like short circuit. So 100 by 100 is 1 e to the power minus T by RC. Okay, because this path has a resistance R and capacitance C. Okay, so the equation for the current via this path is this. It means this current will start from 2 and it will go like this. It will go up to 1 ampere. Okay, it will go up to 1 ampere. Okay, it will go up to 1 ampere. I hope it is clear. It will settle at 1 ampere. Under steady state, it will settle up to 1 ampere. And the thyristor voltage will remain 0. Thyristor will keep on conducting. Fine. And the capacitor voltage, look at the capacitor voltage. So the capacitor voltage will rise to 100 volt. It will rise to 100 volt because under steady state via this path, it will charge to 100 volt and it will increase exponentially to 100 volt. Is it fine, guys? Now after some time, let's say at this instant, you are going to close this. I mean, you are going to turn off this thyristor. So if you want to turn this off, what you are going to do, what you will do is you will fire this thyristor. As soon as you fire it, this capacitor will come in parallel with this thyristor, and this polarity will be like this. I mean, it will reverse bias this thyristor. If you are going to fire it, it will be shorted. If it is shorted, this capacitor voltage will come in anti-parallel with this thyristor. I mean, it will reverse bias. The capacitor voltage will reverse bias this thyristor T1. Okay, it means the voltage across thyristor T1 will get negative. So at this instant, the voltage across the thyristor T1 will get negative. Okay, wait a minute, let me erase this. Okay, so capacitor is charged at 100 volt. This capacitor is charged at 100 volt, and As soon as you fire it, this 100 volt will come in reverse with this thyristor T1, and till the point this thyristor conducts, up to that point you can see that this VCT will come here, okay, and the VT1 is negative of this VCT. VT1 is equal to minus of VCT. You can see that VT1 is of this polarity and VCT of this polarity. This positive point will come here and the negative point will come here. So VT1 equal to opposite of VCT. So VCT is at 100 volt. So VT1 will become minus 100 at this point. Okay. And since the capacitor voltage is changing, because if you are going to fire it, obviously there will be two current. One current is 100 upon 100, that is 1 ampere, and one current is via this path. So via this path the current will be 1 ampere directly. 1 ampere is direct, plus there will be one more current via this path, and via this path this is 100 volt, this is also 100 volt. So initially it will be 2 ampere, 2 e to the power minus T by RC, okay, because for this path the time constant is RC, and under steady state this current will become 0, we know that, okay. So you can see that this will be the current. So now this capacitor current will be opposite, and the capacitor will charge with opposite polarity. Initial voltage is 100, because this is 100 volt, and the steady state voltage via this path, the steady state voltage will become minus 100, opposite polarity. Under steady state it will charge with opposite polarity. So under steady state it will be minus 100 volt, and the time constant for this path is RC. So now you can write the capacitor voltage equation. So the capacitor voltage equation is VCT will be equal to VC infinity plus VC0 minus VC infinity e to the power minus T by tau, T by RC. So this is my capacitor voltage, and the negative of that is VT1. So capacitor is charging from 100 to minus 100. Capacitor is going from plus 100 to minus 100. And the VT1 will go from minus 100 to plus 100. I hope you understood it. Okay, minus 100 to plus 100 via this equation. Okay, because VT1, what is VT1? VT1 is minus of VCT. So if you take the negative of that, you will get 100 minus 200 e to the power minus T upon RC. Okay, this is my VT1. So you can see that at T equal to 0 it is minus 100, and then it will go to at T equal to infinity it will go to plus 100. Now you can see that from this instant to this instant, this VT1 is reverse biased. So this is my circuit turn of time TC. This is my circuit turn of time TC. I hope it is clear. Okay, so this is my circuit turn of time TC. Now you can calculate this circuit turn of time. How to calculate this? You can put this equal to 0 and calculate the value of T. So if you put it equal to 0, then 100 is equal to 200 e to the power minus T upon RC. Now T is equal to RC ln 2. RC ln 2. This is the time. So this is my circuit turn of time, guys. RC ln 2. And it came out to be 100 microseconds. So you can put this value as 100 microseconds. So this has to be 100 microseconds. Okay. Now you can calculate the value of C. So the value of C has to be 100 microsecond divided by R ln 2. R is 100. 100 ln 2. Is it clear, guys? Microfarad. 100 ln 2 microfarad. 100 will cancel. Now you can calculate the value of C. Please tell me what is the value of C. 1 by ln 2 microfarad. 1 by ln 2. What is the value of 1 by ln 2? Please tell me, guys, what is the value of 1 by ln 2? 1 by ln 2. Tell me, what is the value of 1 by ln 2? Is it 1.44? Okay. So the answer is 1.44. 1.44 microsecond. There are many students who just remember this formula. For this circuit, the circuit turn of time for the thyristor is RC ln 2. So if you remember this formula, you can directly apply this formula. The circuit turn of time is already known to us, 100 microsecond. So you can put it 100 microsecond and calculate the value of C. I think it's easy peasy. Okay. So it will take less time. But if you don't know the formula, I don't remember any formula. Believe me, I don't remember any formula. That's why I go with the wave shape. That's why I take extra maybe 1 minute. So, okay. So I hope it is clear to everyone. Now let's come to the next question. Look at this question, guys. Look at this question. In the circuit shown in the figure, the circuit turn-off time for the main and the auxiliary thyristor in microsecond are. So this is the main thyristor and this is the auxiliary thyristor. We need to calculate the circuit turn-off time for the main and the auxiliary thyristor. Again, it's a standard circuit. You must have studied this. You must have studied this circuit. Okay, but so you have to remember the formula. If you know the formula, you can directly calculate it. But I don't remember any formula. That's why I always go with the wave shape. Okay, so let's see how to calculate the circuit turn-off time for the main and the auxiliary thyristor. So we need to check it. Now, tell me guys, how to check it? It's very simple. Let's assume that the capacitor is initially charged. Nothing is provided, so we can assume no problem will be created with that. Okay, I mean, if you are assuming that the capacitor is initially charged with 200 volt, it will create no problem at all. Okay, and it should be provided in the question, I suppose. Okay, so it should be provided that the capacitor is initially charged with 200 volt with this polarity. So if you are going to fire it, what will happen, guys? This thyristor will get reverse biased. This voltage will come across this thyristor now, and the current will flow. One current will flow like this. This diode will become forward bias. One current will go like this. Okay, and there is one more current which will go to the load. So you can see that via this thyristor, the current will be a constant current of 10 ampere plus a sinusoidal current, and sinusoidal current is root C by L. 4 into 10 is to power minus 6 divided by L is 16 micro. Is it clear, guys? Tell me. Sine of 1 by root LCT. In an LC circuit, the peak value of the current is Vs root C by L. I think it's like this: Vs root C by L sine of 1 by root LCT. Do you remember this? Tell me, guys. In an LC circuit, if you have a capacitor and the capacitor is charged with some Vs value, and you have a switch and you have an inductor, so you can see that the current value should be Vs root C by L, or is it L by C or C by L? So you can apply the Laplace transform. You can easily calculate using Laplace transform, and you can calculate this current Is. Okay, you write it Ls, and this capacitor can be written as 1 by Cs, and this initial voltage in Laplace domain, you can write this initial voltage as Vs by S. Okay, so the Is came out to be Vs by S divided by Ls plus 1 by Cs. Using this relation, you can calculate the current equation. Is it fine? I think the current equation is this: Vs root C by L sine of 1 by root LCT. Okay, so this 10 to the power 6 is cancelled. You will get 4 here, and the root of 1 by 4 is 1 by 2, so it will be 10 plus, what is this value? Value of 1 by root 4 is 2, so it will be 100 sine of 1 by root LCT. Okay, this is my current equation. Okay, this is my current equation. Is it correct, guys? Please check it. Is it correct? So this is the current equation, and this current will flow like this. This current will flow like this. So the total thyristor current will be this current plus this current. Now what about the capacitor voltage? The capacitor voltage will be cosine wave. It will start from 200 and capacitor voltage will go like this. Okay, and the current will go like this. Current will be a pure sine wave. It will be like this. Current will be like this. Now tell me, during this period, the capacitor voltage is positive, so it will make the thyristor reverse biased. It will make the thyristor reverse biased. Is it fine, guys? So you can say that this thyristor is reverse biased for this duration. For this duration, the thyristor TA will get reverse biased. So from here you can calculate the circuit turn-off time for thyristor TA. Now what is the circuit turn-off time for thyristor TA? Tell me, guys. This length, this is pi by 2 root LC. Okay, this point, this will be 0 whenever the current will be 0 whenever this point is pi. Okay, so it means the T has to be pi root LC. This is pi root LC. Wait a minute, this has to be pi root LC. Okay, because you can see that now this current will be 0. If this become pi, it means T has to be pi root LC. So this point has to be pi by 2 root LC. It's the middle of that point, no? Pi by 2 root LC. Is it fine, guys? So the circuit turn of time for the thyristor TA will be pi by 2 root LC. So now you can calculate this time pi by 2 root LC. Tell me guys, what is the value? Pi by 2 root LC. L is, what is L? L came out to be 16 micro. Okay, and C is 4 micro. Okay, is it fine guys? So that micro will come out, and 16 root is 4 and this, so it will be 4 into 2 into pi by 2 microsecond. Is it fine guys? So this 2 will cancel, so 4 pi microsecond. 4 pi microsecond. Now what is this 4 pi microsecond? It is 12 point something. So either this option is correct or this option is correct, because for the auxiliary thyristor it is 12.566. Is it correct guys? So we have calculated the circuit turn of time for the auxiliary thyristor. For the auxiliary thyristor we have calculated the circuit turn of time. Now what will be the circuit turn of time for the main thyristor? Now, how to calculate for the main thyristor? Okay, I think it was easy peasy. Let me remove this because this is not of no use, so we can remove this part. Okay, now let's come to the circuit turn of time for the main thyristor. I don't remember any formula, believe me. I just follow the wave shape. If you have understood the wave shape, then you can easily solve it. Now what I need to do is I need to calculate the circuit turn of time for the main thyristor. Now we know that after the end of this cycle, this capacitor is oppositely charged. You can see that this capacitor has become opposite charge. Okay, now the capacitor has this polarity and this current will stop now. This current will stop conducting. Okay, so now you can see that this is charged with 200 volt and the current flowing is only this 10 ampere, and this current has stopped now because this current cannot get reversed, because this diode will not allow the negative direction current. So the current has to turn off at this point. So after this point, the capacitor will remain at this voltage. Capacitor will remain at minus 200 volt, it means opposite polarity. It will remain at opposite polarity, and the current, the capacitor current will remain at 0 and the output current will remain at 10 ampere. So you can say that the current will continuously flow from this side and capacitor will remain at 200 volt. Now what will happen? When you are going to forward bias this capacitor voltage will reverse bias the main thyristor. So at the same instant, this thyristor will get reverse biased. And whatever this capacitor voltage is, that will make the thyristor reverse biased. And now the current will flow via this path. Now the current will flow via this path. This path is RC circuit. You can see that. This is RC circuit. Now what is the capacitor voltage? So the capacitor voltage is, whatever the capacitor voltage is, that voltage will make it reverse bias. Let's say the capacitor voltage is 200 volt. Let's call it positive. Initial voltage is 200 volt. Okay. Now what about the steady state voltage? Under steady state, this capacitor will charge with opposite polarity. Okay. This will charge with opposite polarity. So it will become minus 200. Okay. Or you can take this voltage as negative. This voltage as negative, whatever. It's your choice. You take this voltage as negative and the steady state voltage as positive, because under steady state it will be oppositely charged now. And the time constant for this circuit is RC. R is 20 and C is 4 microfarad. Okay. Now you can write the capacitor voltage equations. VCT is equal to VC infinity plus VC0 minus VC infinity e to the power minus t by tau. Okay. This is my capacitor equation. You can see that at t equal to 0 it is negative. And this voltage will again be the voltage across the thyristor T1. Okay. This is also VT1. So at t equal to 0 you can see that this voltage is negative. It means the voltage across thyristor T1 is also negative. So you can see that this voltage will go like this. Okay. Now calculate this time. Up to what time this voltage remain negative? That time is called the circuit turn of time for the main thyristor. So that time you can easily calculate. Make it equal to 0. If it is 0, you calculate the t value. So t came out to be RC ln 2. RC ln 2. Okay. So it came out to be RC ln 2. You can easily calculate that. Okay. Now RC, what is R? R is 20. And what is C? C came out to be 4 microfarad. ln2. Now you can calculate this value. Okay, please tell me guys, what is this value? Now here the formula will not work. Viswanathan Murli, CVS by I naught. You have used this formula CVS by I naught. This is wrong. Why it is wrong? Because this is valid when the load has a constant current source. Okay, if the load has a constant current, then only this formula is valid. But load has resistance. Okay, when this thyristor will turn off, the RC circuit will work and the capacitor will charge via this equation, and the same voltage will appear across the thyristor. So it will be negative. So the voltage across thyristor, main thyristor, will be negative, and it will go like this. So up in what time it will become 0? That time, up to that time, this thyristor will remain reverse biased, and that time will be the circuit turn off time. So you can easily calculate the circuit turn off time. So that circuit turn off time will be RC ln2. You put the values. Which option is correct? Is it Calcutta? You are saying Calcutta. Okay. So Calcutta answer is correct. I hope it is clear, guys. 0.54. Please tell me, what is this value? Is it 0.54? RC ln2. R is 20, C is 4. So 80 ln2 microfarad, microsecond. Now what is 80 ln2? Tell me guys, what is 80 ln2? Okay, answer is Calcutta. 80 ln2. No. Answer cannot be Calcutta, na? Why? Because 80 is not this, na? This is 80 ln2. ln2 is also there, na? So what is 80 ln2? What is ln2? Tell me guys. Approximately it will become 80. Approximately it will become 80. Okay, so that should be the correct answer. Please check it. Is it 55.45? Okay, 55.5. So I think this answer is not matching with anyone. Okay, wait a minute. VC infinity plus VC 0 minus VC infinity. I think I have made it wrong. VC infinity plus VC 0 minus VC infinity. No. This equation is correct. That's true. And T is equal to RC ln2. That is also correct. R value is 20 and C value is 4. So this should be the correct answer, guys. 55.45. That should be the correct. So this in this option you just modify it. You just write it 55.45. 55.45. This should be the correct answer. Okay, guys. 55.45. I hope it is clear. This should be 55.45. You cannot apply this formula. Why? You cannot apply this formula. Why? Okay, you cannot apply this formula. Why you can't apply this formula? And this answer is given using this formula. And this is wrong. Why it is wrong? Because this 80 would be correct if the load is a pure constant current source. Okay. If the load is a constant current source, then this will be correct answer. And it came out to be 80. It means this is wrong. This 80 option is wrong. Because this load is not a constant current source. It's a R load. So the path is RC. RC path is there. So you can see that the voltage of the capacitor will go exponentially and the same thyristor voltage will also go exponentially. So the answer has to be 55.45. Okay. I hope it is clear to everyone. So please make it correct, and 80 is correct, is not correct answer, because this current will be, this TC will be correct only if you replace this load with a constant current source, which is not the case here. Okay, let's come to the next question, guys. So in this question, again the statement is same. A three-phase controlled bridge rectifier is fed from, wait a minute, I think this diagram is written wrongly. Okay, this diagram is not correct, guys. Okay, this diagram is for the previous question. Okay, so please remove this diagram. Look at the question. Read the question again. Read the question carefully. A three-phase fully controlled bridge converter is fed from three-phase 400 volt 50 hertz. So this is my line voltage RMS value. This is 50 hertz supply. For a firing angle of 60 degree, alpha is given as 60 degree. Okay, output current level is 25 ampere. Okay, average current is 25 ampere, and the output voltage V0T average came out to be 250. Okay, for this converter, the angle of overlap in degrees, mu, I need to calculate. I need to calculate the mu. It means there is a source inductance. There is source inductance should also be there. Now tell me how to calculate the source inductance and the mu. If you know the formula, you can directly calculate it, because, and I recommend you that for the, at least for 3-phase circuit, you should remember the formula. Now, what is the formula? V0T average, that is equal to 3√3 Vm by pi cos alpha minus 3 omega ls I naught, wait a minute, 3 omega ls I naught by pi. Okay, this will be my average output voltage, guys. From this expression you can calculate the value of S, because I naught is known to us, V naught average is known to us, Vm value is also known to us. Vm, what is Vm? √3 Vm is 400√2. √3 Vm is the maximum value of the line voltage, that is 400√2. Okay, so √3 Vm is also known to us, alpha is also known to us, so we can put it here, and the value of Ls we can calculate. So according to my calculation, let me check my calculation, I have get the value of Ls as 2.68 millihenry. 2.68 millihenry. Once you get this source inductance, then you calculate the mu, overlap angle. How to calculate the overlap angle? There is one more formula, that cos alpha plus mu is equal to cos alpha minus 2 omega ls I naught by pi. Please check it. Please check this, whether this formula is correct or not. So you can directly apply this formula and you can calculate the overlap value. Is it fine, guys? Please check it. Is it correct or not? I think this is correct. So you can calculate the mu as 4.81. I have calculated the mu, because we know the value of alpha, we know the value of Ls now. We know the value of I naught. So I think using this expression, you can calculate the mu as 4.81. Is it fine? Sir, V naught will be take as 400 volt. No, 400 volt is the supply side. 400 volt is the RMS value of the line voltage. So the max value of the line voltage is 400√2, and Vm is the max value of the phase voltage. So the maximum value of the line voltage is √3 Vm, and it will be equal to 400√2. This is source side. Okay, you cannot take the output voltage as 400 volt. Okay, is it fine? 400 by √3 is the RMS value of the phase voltage. Just multiply it with √2 also, you will get the value of Vm. Okay, Vm is the maximum value of the phase voltage. So first you calculate the RMS value of the phase voltage. RMS value of the phase voltage is 400 by √3. Multiply it by √2, you will get the maximum value of the phase voltage. Okay, so this is my Vm. So you can put the value of Vm and you can calculate the value of mu, 4.81. Only calculation is there and you can easily solve it. Okay, let's come to the next question, guys. So the previous question was formula based. Let's come to the next question. Question number 9, you can see. In question number 9, a 3-phase half wave phase controlled rectifier is fed from 3-phase 400 volt 50 hertz source. Okay, so we have a 3-phase half wave phase controlled rectifier. Okay, so it is like this. Okay, it is like this, and is fed from a 3-phase 400 volt. So 400 volt is line voltage again, and 50 hertz supply is there. Okay, source is connected to take a constant current of load. Okay, load has a constant current of 30 ampere. Okay, fine. If a freewheeling diode is connected across the load, here we have connected a freewheeling diode. Okay, we have connected a freewheeling diode. I need to calculate the RMS value of the freewheeling diode for alpha equal to 60 degree. Alpha equal to 60 degree, and we need to calculate the RMS value of the freewheeling diode current, IFD. We need to calculate IFD. Tell me, guys, how to calculate this? It's very simple. We know that, look at the output voltage first. Without freewheeling diode, let's first plot the output voltage without freewheeling diode. So the phase voltage will be like this. At the output you will get the phase voltage and it will be like this. I don't remember any formula, so you can go with the wave shape, no problem with that. Okay, this is VAB. Oh, this is VAN. Wait a minute. This is VAN. This is VAN. This is VBN, and this is VCN. Now we know that alpha is equal to 60 degree. If alpha is equal to 60 degree, and if you assume that there is no freewheeling diode, alpha is measured from this point. So at this instant, you have fired the thyristor T1, at this instant you have fired the thyristor T2, at this instant you have fired the thyristor T3. If there is no freewheeling diode, the voltage will be like this. For alpha equal to 60 degree, this will be my voltage. Is it fine, guys? But you know that there is a freewheeling diode. So from this point to this point, there is a 30 degree interval. There is a 30 degree interval. During this 30 degree interval, the freewheeling diode will conduct and the output voltage will be 0 during this interval. Okay, if there is a freewheeling diode, voltage can never go negative. Okay, so during this 30 degree interval, the freewheeling diode will conduct. I hope it is clear. The voltage will not go negative. Okay, the voltage will not go negative. I hope it is clear. So 30 degree interval, freewheeling diode will conduct and the current value will be 30 ampere. Now if you plot the current wave shape, if you plot this IFD current will be, during this 30 degree current will be 30 ampere and it will repeat after 60 degree interval. After 60 degree it will repeat again. Okay, so the period is 60 degree. The period is 60 degree. So you can see that this length, during this length freewheeling diode will conduct and the same thing will repeat here. Okay, so the period is not 60, it's 120 degree. Wait a minute, guys. So the period is 120 degree. After 120 degree, because AN and BN, it has gap of 120 degree. So after 120 degree, again 30 degree freewheeling diode will conduct. Okay, so this period is 120 degree or 2 pi by 3. Okay, the period is 2 pi by 3 and this length is pi by 6. So tell me, what is the average value of this? Not average, RMS value of the freewheeling diode current. So how to calculate the RMS value? It's very simple. 1 upon 2 pi by 3 and you need to take the integration from, let's call it 0 to pi by 6. Okay, the period is 2 pi by 3 and 0 to pi by 6, the current is 30. So take the square of 30 d omega t and take the root. This is my RMS value. So you can calculate this value. It came out to be 30 root of 3 upon 2 pi into pi by 6. Is it fine, guys? This pi will cancel. This will be 2. So it will be 30 by 2. 30 by 2 is 15 ampere. Okay. So RMS current came out to be 15 ampere. Is it fine, guys? I think this was easy peasy. Using the wave shape, you can comment. Using the wave shape, you can easily comment. I hope it is clear. Let's come to the next question, guys. So look at this question. A 2-pulse converter supplies RLE load. So we have RLE load and this is the converter I have. This is the converter we have. Okay. And the load is RLE. Is it fine? The load is RLE. R is of 5 ohm. Okay. L is of 20 Henry. 20 Henry, it's very large. It is 160 volt. Okay. From a 220 volt, 50 hertz. So here the source is 220 volt RMS, 50 hertz. This is my supply. Fine. The load draws an average current of, so this current is given as, average current is given as 7.614 ampere. Okay. And the value of E is changed. If the value of E is changed to this value, new value of I naught, we need to calculate the new value of I naught. Tell me, guys. So what he done it? What he has done it? He has decreased the value of E. So we are assuming, then since this L is very high, na, so we are assuming that the conduction is continuous. Okay. Okay. In the previous question, how the period is 2 pi by 3? Okay. Let me tell you, guys. In a half controlled rectifier, the period is 120 degree. So the freewheeling diode will conduct after 120 degree. This length is 120 degree. This gap is 120 degree. So after each 120 degree, the freewheeling diode is conducting. Okay. This point will repeat at this point. So this length is 120 degree. I hope it is clear. Okay. So that's why the period is 120 degree. Okay. Now let's come to this. Let's come to this question. Previously it was 160 and the average current was this. We know that average voltage across inductor is 0. So what is the average output voltage? V naught T average in the first case, that will be equal to 160 plus 7.614, which is average current, into the resistance value, into 5. Okay, this is my average output voltage. It will remain fixed. Now in the second case, this average output voltage will remain fixed because alpha is fixed. So this average output voltage will remain fixed. But in the next case, what I've done is, in place of 160, I have 155, and the current is changed to I naught. Okay, now it will become this, because E is 155 and the current will become I naught into 5 plus 155 is the average output voltage, and the average output voltage will remain same as this value. Now you can calculate the value of I naught. Tell me guys. So I naught you can easily calculate. I naught. Now how to calculate I naught? This will be I naught is equal to 1 by 5 of, tell me, on this side it will be 10 plus 7.614 into 5. Is it clear guys? So you can see that this is approximately 35 or 38 plus 10, 48 by 5. 48 by 5 is, what is this value? 48 by 5. It is 8 point something. So answer is Bombay, I suppose. Answer is Bombay. Please check it. Answer is Bombay. Okay. So this way you can easily calculate the value of I naught, average current. I hope it is clear to everyone. Okay guys, let's proceed. Let's come to the next question. Okay, now I have taken 5 questions from electrical machines. So I have taken 10 questions from power electronics. I hope you enjoyed these questions. Now I'm going to solve questions of machines, electrical machines. So look at this first question guys. Look at this first question. A 3-phase 50 Hz 4-pole alternator with 3 slots per pole per phase has 4 conductor per slot with a double layer winding. Okay, the coil span is 6 slot and the flux per pole is this. EMF per phase I need to calculate. Okay, we know that the EMF per phase is root 2 pi f n phase phi per pole kW. Okay, this is the formula for induced EMF per phase. Now if you look at this carefully, there are 3 slots per pole per phase. Q value, Q is given as 3. Now can you tell me the total number of slots? Total number of slots, tell me guys. Total number of slots are 3 into 3, this phase is 3 and the pole is 4. So tell me, this will be 36. So the total number of slots I have calculated from this relation. 3 is the number of slots per pole per phase. Per pole per phase. So I have multiplied with pole and phase. You will get the number of slots. So there are total 36 slots. Each slot contains 4 conductors. So the total conductor is 4 into 36. Is it fine guys? So the total conductors are this. And we know that the total turn will be 4 into 36 by 2. So it will be 72 turns. So there are 72 turns. Total turns are 72. Is it fine? Now the turns per phase. I require turns per phase. How to calculate the turns per phase? So the turns per phase will be, tell me the turns per phase. Turns per phase will be 72 divided by 3. So it will be 24. 24 turns. So we have calculated turns per phase, N phase. Phi per pole is already known to us. Frequency is already known to us. Now I need to calculate kW. kW is equal to, what is kW? kW is kd into kp. Okay, so first let's look for kp. Coil pitch factor. Kp is equal to cos of epsilon by 2. Now can you tell me the coding angle? What is the coding angle? Coil span is given as 6 slot. There are total 36 slot. Can you calculate the electrical angle per slot? So the total mechanical angle is 360 degree. Per slot the mechanical angle is 10 degree. But we require electrical angle. So electrical angle per slot is P by 2, no? 4 by 2, P by 2. So this is my angular slot pitch gamma. This is my angular slot pitch. Per slot electrical angle. Total 360 is the mechanical angle and total slots are 36. Total slots are 36. Okay. So this is the mechanical angle per slot. Multiply it with P by 2, electrical angle per slot. We call it angular slot pitch. So the angular slot pitch came out to be 20. Okay. This came out to be 20 degree. Is it fine? For per slot, electrical angle is 20 degree. Now, coil span is 6 slot. 6 slots mean 120 degree electrical. It means the coil is short pitched. It means the coil is short pitched and short pitched by 60 degree. So the coding angle is 60 degree. Okay. If you know the coding angle, you can easily calculate Kp. So Kp came out to be cos 30 degree. So we have calculated Kp. Is it fine, guys? Kp came out to be cos 30. Cos of epsilon by 2 is the Kp. Now let's come to Kd. Kd is sine of q gamma by 2 divided by q sine gamma by 2. If you remember the formula, q is 3 and gamma is 20. So it will be sine 30 divided by q. Q is 3, sine 10 degree. Okay. You can calculate the value of Kd. This is my Kd value. So we know the Kd, we know Kp, we know the number of turns per phase. You can put the value here and you can calculate the RMS value of the phase voltage. Is it fine, guys? So can you calculate this value? Root 2 pi f is 50. Number of turn per phase is 24. Flux per pole. What is flux per? It's 0.1 Weber into Kw. Kw is cos of 60 into cos of 30. Wait a minute. It should be cos of 30. Cos of 30 is the Kp and Kd is sine 30 divided by 3 sine 10 degree. Okay. So this way you can calculate the value of induced EMF. Is it fine, guys? I hope it is clear. So this question was very simple. You can calculate the induced EMF per phase. Can I proceed, guys? Tell me. Can I proceed? Let's come to the next question, guys. Let's come to the next question. So I have calculated the induced EMF per phase. Let's come to the next question. Look at this question, guys. Look at this question. A 3-phase stator winding has 9 slot per pole. So we have a 3-phase stator winding, 9 slot per pole. Okay. And employs 10 turns coil. Okay. With a coil span of 7 slot. It means the coil is short pitched by 2 slot. Because 9 slot per pole. Per pole means 180 degree electrical. One pole cover 180 degree electrical. 9 slot cover 1 pole. It means 180 degree electrical. For 180 degree electrical, you require 9 slots. And the coil span is 7 slot. It means you can say that coil is short pitched. Coil is short pitched. Okay. Short pitched. Now, can you calculate the epsilon? So the epsilon is short pitched by 2 slot into gamma, angular slot pitch. There are 2 slots, na? Short pitched by 2 slots. So 2 into angular slot pitch. What is electrical angle per slot? Now how to calculate that? We know that for 9 slots, electrical angle is 180 degree. How we know that? Because 9 slots are per pole, na? One pole has 9 slots. It means 180 degree electrical is equal to 9 slot. Sir, please calculation once more. No. You do your calculation. No? I have done everything. So please do your calculation. Okay. I have done it everything, Viswanathan. Okay. So you do your own calculation. Okay. I have done it myself. Okay. This calculation I have done it. You can check your answer. What should be the answer? You can check it here. Okay. Everything is simple. Okay. I think I have done it correctly. You just do the calculation. No? The calculation part is your. Okay. Everything I have done it. Now let's come to the next thing, guys. The next question is, it is given that 9 slot per pole. It means 9 slot are covering 180 degree electrical. 1 slot is covering 20 degree electrical. Fine. And 2 slots are covering 40 degree electrical. So epsilon came out to be 40 degree. Is it fine, guys? Epsilon came out to be 40 degree. Is it fine? Epsilon came out to be 40 degree. Because we know that the coil span is 7 and 180 degree. One pole means 180 degree electrical means 9 slot. So 9 slots are covering 180 degree. 1 slot will cover 20 degree electrical. And the coil is 2 slots short pitched. So the coding angle is 40 degree. Okay, I hope that you have understood this. Okay. Now, this is my coil span, the coding angle. Induced EMF in each stator conductor is sinusoidal, okay, and has the RMS value of 8 volt, okay. It means each conductor has RMS value of 8 volt. Now look at this. Look at this, guys. We have an alternator. It's a 3-phase alternator. One side, if one side is this, A side is this, then A prime side will not be opposite, because then it will be full pitch coil. Now let's say the number of pole are 2, because the number of pole are not given. So let's take P as 2. So if you take P as 2, then if one side is here, then the other side should not be at this position, because the coil is short pitched by 40 degree. So the other side should be 40 degree short pitched. Is it fine? This angle is 40 degree. So A prime has to be at this location. I hope it is clear. Now it is given that the RMS voltage of 8 volt, the induced EMF in each stator conductor is sinusoidal with RMS value of 8 volt. In this stator conductor, let's say here you have one stator conductor. In that stator conductor, RMS value is 8 volt. So the peak value is 8 root 2 sine of omega t. 8 root 2 sine of omega t. In one conductor, this is the voltage. And in this side, the voltage will be 8 root 2 sine of omega t minus, since it should be 180 degree. If it is here, it should be omega t minus 180 degree. But since it is not just opposite, it is 40 degree away from that. So it should be 140 degree. Okay. So the voltage induced in this conductor is this voltage. I hope it is clear. Voltage induced in this conductor is this 8 root 2 sine omega t. Then the voltage induced in this conductor will be 8 root 2 sine omega t minus 140, because it is 140 degree away. You can see that. If the coding angle is 40 degree, then electrical angle between these two sides is 140 degree. Okay. So we have written the voltage in per conductor, but actually there are 10 turn coil. The coil is of 10 turn. It means 10 conductor on this side and 10 conductor on this side. So this side voltage is 80. You replace it with 80 and you replace it with 80. I hope it is clear. So this is 80 root 2 sine omega t, and this side is also 80 root 2 sine omega t minus 140 degree. Now I need to calculate the coil voltage, RMS value of the coil voltage. So you first take the difference. This is A side, this is A prime side. So VA minus VA prime is equal to VAA prime. Okay. So we have calculated the voltage difference between two phases. Two sides. Okay. So this is the coil voltage. Now this is the max value. 80 root 2, take this out, 1 angle 0 minus 1 angle minus 140. This is the peak value of the coil voltage, divided by root 2 is the RMS value. So it will be 80 into 1 angle 0 minus 1 angle minus 140. Is it fine, guys? You can calculate this. Please tell me what is this value. Please tell me what is this value. I don't know how many of you have understood it. I don't know how many of you have understood it. So it's a simple question. You can easily solve it. Tell me, guys. Tell me what is this value. Tell me what is this value. Tell me, everyone. Tell me. Actually, the coil span is 140. Na? Coil is short pitched. Now, can you calculate the value? Can you calculate? The distribution factor is not there. Na? Distribution factor is not there. What you can do? There is one more option. Na? There is one more way you can solve it. We know that. Let's take the coil as full pitched coil. If the coil is full pitched, then the voltage will be 80 root 2 sine of omega t minus 80 root 2 sine of omega t minus 180. So it will be added. So it will become 2 into 80 root 2. This is the peak voltage. This is the peak voltage of the coil. If the coil were full pitched, now you just multiply it with cos epsilon by 2. So the voltage will be 2 into 80 root 2 into cos of epsilon by 2 kp. Cos of epsilon by 2 is cos 20 degree. This is the maximum value of the coil voltage divided by root 2. Divided by root 2 you can do. So to calculate the RMS value. So you will get the RMS value like this. 160 cos 20, 160 cos of 20 degree. This is my answer. There is other way also. Na? First you assume that the coil is full pitched. If the coil is full pitched, in one side this is the induced voltage. In the other side, this is the induced voltage. It's just 180 degree away. So I have subtracted the 2 voltage and I will get this voltage, double of that. So 2 times of 80 root 2 is the maximum value of the coil voltage. If the coil is full pitched, we know that the coil is short pitched. So we multiply it with cos 20, cos of epsilon by 2. Okay. So, and divide by root 2 to get the RMS value. So that root 2 is cancelled. You will get 160 cos 20. You can directly calculate this. Okay, and you can also calculate like this also, no? Because we know that the other side is not at 180 degree, it is at 140 degree away. So you can write it like this. You can take the difference, divide by root 2 to get the RMS value. You can easily solve it. Okay, so whatever method you can apply. So tell me the answer. Is it Agra? Okay, if the answer is Agra, that's fine, no problem. Let's come to, yes, cos 180 means minus. Cos 180 is negative sign, so it will be added. Cos 180 is negative, na, minus. So you can remove this 180 and you can add it. So it will become double. It will become double. Okay, I hope it is clear to everyone. Let's come to the next question, guys. In this question, a 1000 kVA, 11 kV line to line, 3-phase star connected synchronous motor. So we have a synchronous motor, star connected, has an armature resistance and reactance per phase of this and this. So armature resistance per phase is equal to 3.5 ohm and the synchronous reactance came out to be 40 ohm. Okay. Now the motor is operating at rated condition at unity power factor. Then the load angle and electrical angle is. So it's very simple. Motor is operating at unity power factor at rated load. Rated load means the current is rated. What is the rated current, guys? So the rated, this is my rated power. So 1000 into 10 to the power 3 is equal to root 3 VLIL. What is the rated voltage? It is 11 into 10 to the power 3. This is the line voltage and into the line current IL. So this 10 to the power 3 is cancelled. You can calculate the line current. So the line current is 1000 divided by 11 root 3. This is my line current. This is my rated line current. And since the machine is connected in star, so this is also the phase current. Okay, this will also be the phase current. I hope you understood it. This will also be the phase current. So I have calculated the line current and the phase current, and this is the rated current. Now you know that machine is operating at unity power factor. So if you draw the machine diagram, this is my terminal voltage VT, and here you have the resistance and the reactance, and this is my internal voltage EF. Okay, this is my EF. Now let's assume that this voltage is at 0 degree. Okay, and this voltage and this current is a rated line current, rated phase current at an angle of 0 degree. And VT is the phase voltage, 11 root 3, 11 by root 3. This is my phase voltage. We need to calculate this delta. We need to calculate this delta. So it's very simple. You just apply KVL. 11 by root 3 into 10 to the power 3 angle 0. This is VT minus IL. IL is 1000. 1000 by 11 root 3. This is my IL angle 0 into this impedance, and this impedance came out to be 3.5 plus J 40 plus J 40. So this will be EF angle minus delta. I have applied the KVL. Okay, since it's a motor, so I have applied the KVL. You can calculate this minus delta. Okay, you can calculate this minus delta. How much angle this came? Is it C? Is it Calcutta? Because Vishwanathan is getting Calcutta answer. So you can apply direct KVL, no? You can apply direct KVL and you will get the angle delta. I think it's easy peasy. Okay, so this is easy peasy and you can easily solve it. You just have to apply the KVL and you will get the answer. I hope it is clear. You just solve it. Okay, nothing new. We need to find this delta. Okay, let's come to the next question. So the next question is, look at the next question, guys. An 8-pole synchronous motor with an induced EMF per phase. This is the per phase induced EMF. Okay, and synchronous reactance of 11 ohm. Okay, is floating at an infinite bus. Floating means there is no current. There is no current. EF is equal to VT. Okay, EF is equal to VT, and this is the induced voltage. This is my EF. EF came out to be, tell me, 3300 root 3 per phase. This is per phase voltage. Per phase EF is given. Okay, synchronous reactance is of 11 ohm and it is floating. Floating means angle is delta and EF is equal to VT. Neither it is working as motor nor alternator. Okay, now it is given that the shaft load of the motor is suddenly increased. So I have increased the shaft load. Obviously, if you are increasing the shaft load, then there will be some active power out from the motor and there will be some delta. Okay, for load angle of 1 degree mechanical, for the load angle of 1 degree mechanical, the synchronizing current is, what will be the current? So now Look at this angle, 1 degree mechanical. So can you calculate the electrical angle? It will be 8 by 2. So it is 4 degree electrical. So this is my 4 degree electrical. Delta is given. It means VT will remain on this side and EF will go on this side. EF will move on this side. And this angle is 4 degree electrical. Okay. This is my EF, this is my VT, and ET and VF were equal because you are not changing ET and VT and EF. You are not changing that. Only the delta is shifted. Delta becomes 4 degree electrical. Now, I need to calculate the synchronizing current. How to calculate the current? This length is called GATE axis. Okay. Now, you can calculate this GATE axis. How to calculate? We know that this voltage is 3300 root 3 angle 0. Okay. This is my VT. Minus GATE axis is equal to EF, 3300 root 3 angle minus 4 degree. Is it fine, guys? So from there you can calculate this current. I hope it is clear, guys. You can calculate the current. Axis is already given to us now, 11. Axis is already given to us. So now you can say that GATE axis is equal to 33 root 3. Take this common. This is 1 angle 0 minus 1 angle minus 4 degree. You can calculate it like this. And take this J axis in the denominator, you can calculate the value of IA. Is it fine, everyone? So this way you can calculate the value of IA. It's just a matter of calculation. You can do it yourself. You can do the calculation. I hope it is clear to everyone. Let's come to the next question, guys. Let's come to the next question because I don't want to do the calculation part. Calculation is your part. Okay. I'm just telling you how to solve this question. Okay. Sir, why magnitude of EF and VT same? Because it was floating previously. When the machine is floating, it means it is neither taking the current nor it is giving the current. It means there is no drop. There is no drop in the machine. This is the equivalent diagram of the machine, na? Per phase equivalent diagram. So if it is floating means the current is 0. This is VT, this is EF. Floating means the current is 0. If the current is 0, there is no drop here. So this voltage and this voltage will be equal. Okay. That's why I have taken same magnitude as VT and EF are of same magnitude, and then I applied a shaft load. So I have not changed the VT, I have not changed the EF, the only delta will change. Okay. If you have applied the shaft, then delta will change. So delta 0, so current 0 now. Yes, previously when it was under floating condition, there was no current. There was no current. Okay, there was no current. You can see that there was no current. ET equal to VF, delta was 0. Now you applied shaft load. Because of that shaft load, EF is shifted back. EF is shifted back. Okay, and there is a 4 degree difference. Now you have GATE axis. Now you have the current. Is it fine? Now you will have the current, and you can easily calculate that current. Okay, using the KVL expression, you can easily calculate that current. Okay, let's come to the next question, guys. So the next question is again very simple. Look at this. Two synchronous generator, each with an induced voltage per phase of 200 volt. Okay, so there are two synchronous generator, each voltage is of 200 volt. Resistance per phase is 1 ohm, and the synchronous reactance is of 1 ohm again. Are synchronized and operating at no load. So they are connected in parallel. Okay, they are synchronized, connected in parallel, and they are operating at no load. Okay, synchronized means they are running in parallel. Okay, and they are working on no load. Now the prime mover input of machine 1 has a step increase. We have increased the input of machine 1, resulting in a voltage advancing in phase by 5 degree electrical. Okay, it means the voltage of this alternator, the first alternator, is shifted 5 degree away. Okay, the synchronizing power received by machine 2, if resistance is neglected per phase, it means there is no resistance. You can neglect this resistance. There is no need for this. Okay, so now we have two alternators. Each alternator has some reactance of 1 ohm and some induced voltage of 200 volt. Okay, and here also you have J1 ohm and an induced voltage of 200 volt. Is it fine, guys? They are operating at no load. There was no load, so there was no circulating current, and this voltage was, let's say, 0 degree. This will also be at 0 degree. There will be no circulating current, and there was no load connected here. Now what we have done is we have increased. Now the prime mover input of machine 1 has increased. Now we have increased the prime mover input of this machine. So obviously if you have increased the prime mover, so this will give active power. It means the angle of this quantity will increase. Okay, this is EF na, EF will not change, the magnitude will not change, only the angle will change. Let's call it 200 at an angle 0. This is 200 at an angle 0, and this voltage will go to 200 at an angle of 5 degree. Okay, 200 at an angle of 5 degree. It will move on the circle. Okay, on the circle it will be moved on this side. Is it fine, guys? So you can see that this voltage is shifted to 200 angle 5 degree because you have increased the input power of this alternator. Okay, now I need to calculate what is the power received by the, now you can calculate what is the active power supplied by this machine. So it's very simple. This side is 200 angle 5 degree now, this side is 200 angle 0, and the reactance is J2. So this is my sending end voltage, this is my receiving end voltage, and the reactance is J2. So the active power will be EF Vt by XS sine delta, if you remember. EF means sending end side. So sending end voltage is 200, receiving end voltage is also 200, divided by XS is 2, the path reactance is 2, and sine delta, sine 5 degree. Is it fine, guys? This much of watt is the power. Okay, multiply by 3 because it's a 3-phase. Is it fine? Because it's a 3-phase alternator. But per phase is asked, so you don't need to multiply with this 3 because the power per phase is asked. Wait a minute, the synchronizing power received by machine 2 if resistance are neglected per phase, it means the power per phase is asked, so you don't multiply with 3. Okay, so you can easily calculate what is this value. Okay, I hope it is simple. I hope it is simple. So these were the questions, guys, and now just give me 1 minute so that I can contact to Ashu Sir, and now Ashu Sir will continue. Just give me 1 minute. Just give me 1 minute, and before that, let me tell you guys, you can join the test series by BYJU'S Exam Prep. BYJU'S Exam Prep is also providing you the good test series, and in this test series you will get 60 plus tests along with the mock test and the subject wise test. So there are many tests, and there are 4,000 plus questions for practice, so you can join it. There are some other features also. Virtual scientific calculator you will get, and detailed mock analysis is also there. All India open mock tests are also there, so you can join it. It is the synchronizing power now, EV by X cos delta na. No, that EV by X cos delta is synchronizing coefficient, not the synchronizing power, Viswanathanan. Don't make mistake. Okay, EF Vt XS cos delta, you are taking cos now. The cos delta is synchronizing power coefficient. That is not synchronizing power. That is synchronizing power coefficient. Okay, I hope it is clear. That is called synchronizing power coefficient. Okay, so I hope it is clear to everyone. So now I think Ashu Sir is ready. So there will be a glitch of maybe 10 second or 20 second, guys. So don't leave the class and wait for Ashu Sir to join, and then from this point onwards Ashu Sir will continue. But don't forget to like this session, and don't forget to subscribe our channel. I thought that we can make the half century of likes, but anyway, it's 34. So don't forget to like this session, guys. Now from this point onward, Ashu Sir will continue. So let's stop it here, and let's give it to Ashu Sir.
Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are live with me, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. So till now you were with one of the legendary faculty for electrical engineering, Ashu Sir, and I was watching the session for last couple of minutes, and I saw that very good quality questions sir was discussing with all of you. So you must be getting full confidence for the upcoming GATE examination. Yes or no? So, Murli, please use a good quality earphone. I think it's visible from my side. I have checked it on my mobile. It is okay. So, before we start the session, I want to congratulate to all of you on this 74th Republic Day. And I hope you all must be well prepared for the upcoming GATE 2023 examination. And this session, we are going to discuss some of the important questions related to the core subjects. For example, Sir has discussed power electronics and electrical machines. I will be discussing power system and few questions from electrical machines. So next year you are going to have the 75th anniversary of the Republic Day, 26th of January 1949 was the year, and it was 1950 when for the first time our constitution was enacted. Shubham, I think my voice is okay from my side. Let me check on my mobile. Shubham, I think my voice is okay. It is okay. It is okay. You please use a good quality earphone. Okay. So without wasting much time, let us start with the session. So some of you may be joining me for the first time. So there is a brief introduction about myself. My name is Ashu Sir. As you can see on the screen, I have 11 plus years of teaching experience. MTech from ITBHU in 2010, written a couple of books, and these are my areas of expertise. Before we start the session, some important information about the BYJU'S Exam Prep Mega Mock Challenge All India Open Mega Mock Test for 2023, which is going to be conducted from 24th of January to 30th of January. In order to attend these mega mock tests, you have to get yourself registered on the BYJU'S Exam Prep app. Everybody's favorite and my favorite faculty, Rakesh Talleja sir, is going to conduct a mega workshop on 29th of January, 12:30 p.m. 29th of January, 12:30 p.m. in the afternoon on the 7 golden rules to secure a single digit rank in GATE 2024. So if you are interested in this workshop, uh, get yourself registered. And once again, one of the most awaited sessions throughout the year, the live exam analysis for GATE 2023, electrical, electronics, instrumentation, computer science, all the branches. We are coming up with the complete exam analysis on 5th and 11th of February, 1 a.m. and 6 p.m. in the evening. So everybody just quickly hit the like button, hit the bell icon and subscribe to BYJU'S Exam Prep so that you do not miss any of the important session. So let us talk about the first question. The first question says a 4-pole lap wound generator is running at 900 rpm if the self-inductance is this much and the armature current is given. Number of commutator segments are mentioned. The width of the bridge is 4 segments. Then what is the reactance voltage? How we are defining the reactance voltage? The reactance voltage we are defining as L di by dt, where L is the self. Shubham, I will give you the opportunity, okay? In the later part of our discussion, let us first do the questions. Personal questions, you can join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Saxena. Or you can personally ping me also, okay? Just join this Telegram channel and ping me what is your doubt personally. For personal doubts, I think we have to deal it separately. Doubts which are related to the questions we are discussing, that are most welcome right now, because already the class has been for more than 2 hours, you can say. So I have to finish it very fast. So reactance voltage you are defining as L di by dt, where L is the self-inductance of the, please cooperate Shubham, self-inductance of the commutating coil. Yes or no? Now what is this di by dt? Okay Shubham, I will explain, don't worry. Now what is this di by dt? Let us understand. If you see the current in the commutating coil, suppose this is IC and this is the time, then you will understand that commutation is nothing but the complete reversal of current in the commutating coil. So suppose starting it was plus IC, and at the end of the commutation period it is minus IC. This period of time when the current is completely reversed, we are defining as the commutation period. This is the complete picture. Now if I have to write the reactance voltage, you can write it as L. Now what is the total change in current? The total change in current is going to be minus IC, that is the final current, minus initial current is IC, divided by time of commutation, that is the commutation period. So you can write it as minus L 2IC by DC, that is the commutation period. Now if you see the question, the data given in the question, IC is nothing but the current in the parallel path. So the total armature current divided by the number of parallel paths is going to give you the current in the each parallel path. Total armature current is 108 amperes. It is divided by number of parallel paths because it is a lab bound machine. So number of parallel paths is equal to number of poles, that is 4. So divided by 4. So it becomes 4 दूनी 8, 2 28, 4 7 28, 27 amperes is going to be the current in each parallel path. Now the self-inductance is also mentioned. The self-inductance of the commutating coil is also mentioned here. That is 153 10 to the power minus 6 henries. It means in this equation you have all the data except this commutation period. How to find the commutation period? It is very interesting. Listen very carefully. If this is your DC machine, suppose this is the armature, and suppose it is a 2-pole machine, something like this, north pole and south pole, and these are the brushes. He is talking about a generator or motor. Let's check. He is talking about a generator. No problem. Now the commutators are placed. How the commutators are placed? Yes, the commutators are placed along the periphery of the armature. I am just making it quite randomly, so don't get disheartened, just to make you understand how the commutator segments are going to be. Yes or no? Now he is giving you the speed at which the rotor of this generator is rotating. The speed is 900 RPM. So you can say 900 RPM means in 1 minute the machine is having 900 revolutions. Can you tell me what is the time duration for one revolution? Yes, it is going to be 1 upon 900 minutes, or you can say 60 upon 900 seconds. Yes or no? This is the time for one complete revolution. Now, if you are a stationary observer and you are standing here, can you tell me in one complete revolution, how many commutator segments you are going to see? You are going to see total number of commutator segments, that is 55. So all the 55 commutator segments you are going to observe. So for passing 55 commutator segments, the time is 60 upon 900 seconds. Can you tell me the time for one commutator segment? Yes, it is going to be 60, 900 divided by 55 seconds. Now the time for passing one commutator segment you have got, and the brush width, because if this is your commutator, these are the commutator segments, and suppose this is your brush. This is your brush. Commutator is suppose moving in this direction. So when this brush is going to be coming to the next commutator segment, this total time duration will be the commutation period. It means the total time for crossing the brush width is going to be the time for commutation period. The brush width is given as 1.74 commutator segments. So can you find the time for passing 1.74 commutator segments? Yes. For 1.74 commutator segments to be passed, the time is going to be 60 upon 900 into 55 multiplied by 1.74 seconds. And this is going to be the commutation period. Yes, Ram. Very interesting name. So everybody is getting that? Once you get the commutation period, you have the self-inductance of the commutating coil, you have the current in each parallel path. Can you calculate the reactance voltage? Yes or no? As per my memory, what I can remember is you must be getting the answer as B option. 3.915 should be your reactance voltage. Everybody is getting that. Shubham and Ram, what you are getting is 0.00212. That is the commutation period. 0.00212. Okay, let us go to the next question. Calculate the number of conductors on each pole piece required in a compensating winding for a 6-pole lap-bound DC armature containing 286 conductors. The compensating winding carries full armature current. Assume the ratio of pole arc pole pitch. Now please see. What is the basic idea of compensating winding? What is the basic idea of compensating winding? Suppose this is your pole. Now there will be slots in the pole shoe where you will be placing the compensating winding. And suppose this is your armature. Armature, you will be having the armature conductors. The polarity of current, suppose in the compensating winding is dot, and the polarity of current in the armature conductor is cross. We are assuming it, okay? It should be opposite. So what is happening? If you see for the compensating winding, because it is dot, so apply the right hand thumb rule, thumb in the direction of current and fingers moving in the direction of flux. So it will be anti-clockwise. So the compensating winding current is going to be in this direction anti-clockwise. And if you see the flux because of the current in the armature conductors, it is going to be clockwise, something like this. So you can see that compensating windings are neutralizing the cross magnetizing effect of the armature reaction under the poles in the polar region. Now, very interesting part I am going to discuss. Suppose this is your armature, and now I am taking a 4-pole machine. Now I am taking a 4-pole machine. Something like this. It is a 4-pole machine like this. Now you must be aware that for DC machines, we have the closed windings. Closed winding is going to be something like this. This is the armature closed winding, okay? Now this armature winding, I want to know the ampere turns of the armature winding. Can you tell me what is the ampere turns of the armature winding per pole? It is per pole. Can you tell me what is this? Listen very carefully. What is ampere turns of the armature winding? Number of turns of the armature winding, yes or no? Number of turns of the armature winding multiplied by the current in each turn. Now suppose it is a 4-pole machine, so the number of parallel paths are suppose 4 if it is a lap bound machine. I'm just giving you one random example. So the current which is flowing in one parallel path is going to be the current which is passing through any turn, yes or no? The current which is in one parallel path, that is going to be the current which is flowing in one turn. So first, what is the number of turn? If Z is the total number of conductors, now one turn requires 2 conductors. Yes or no? So 2 conductors are required to have 1 turn. If there are total Z number of conductors, then what is the number of turns? Number of turns will be Z by 2. What is the current flowing in one turn? That is IA divided by A. This is the total ampere turns of the armature winding. But I am asking you the ampere turns of the armature winding per pole. So you have to divide it by P also. So always remember the ampere turns of the armature winding per pole is going to be IAZ upon 2AP. But there is a problem. What you have found as the ampere turns, what you have found as the ampere turns of the armature winding, and you have divided by number of poles. Now what you are getting is, for example, let me use another color. It's not looking good. Which color should I use? Okay, the green one. So basically it gives you the ampere turns of the armature winding for one pole pitch. Yes or no? For one pole pitch. But your pole is only present for this pole arc. Yes or no? It means if you want to compensate, what is the ampere turns of the compensating winding? Ampere turns of the compensating winding. Ampere turns of the armature winding per pole, and you have to rationalize it for the pole arc. So you have to divide it by pole pitch and you have to multiply it by pole arc. I hope you are getting the explanation. What is this hara? Okay, you're asking the color. Or you're telling the color. That's very interesting to know. Great. So it should be pole arc, yes or no? Ampere turns of the compensating winding, how you are writing? Suppose the number of conductors in the compensating winding is ZCW. CW stands for compensating winding. Divided by 2, that is the number of turns. What is the current in each turn? Because compensating winding is connected in series with the armature winding. So the current in each compensating winding turn is going to be armature current. This should be equal to pole arc upon pole pitch and multiply it by ampere turns of the armature winding per pole, that is IAZ upon 2AP. Armature current is cancelled. This 2 is also cancelled. So compensating winding number of conductors will be pole arc upon pole pitch is given as 0.7. Total number of conductors, I think it is 286. Divided by number of parallel paths. Number of parallel paths, it is a 6-pole lap bound. So number of parallel path is 6. And number of poles is 6. So can you calculate the number of conductors in the compensating winding? Approximately you will be getting 6. Approximately, not exactly. So closest integer you have to choose. So I think C is going to be the correct answer. Is it clear, everybody? Okay. That's great. See the next question. Find the number of poles from a 1200 kilowatt generator. The average voltage between commutator segment is 15 volt. And the armature ampere turns per pole is 10,000. So the first equation you can easily make. That is ampere turns of the armature winding IAZ upon 2AP is directly given as 10,000. So this is equation number 1. He is giving you the rating of the machine 1200 kilowatt. So if you know the generated EMF and if you know the armature current, this is going to be 1200 kilowatt. 1200 kilowatt. Now, how you are writing this E, please understand. Very interesting part is going to come. Please see very carefully. He is telling you that the average voltage between commutator segment is 15 volts. So if this is your commutator, if these are your commutator segments, and one interesting information also he is giving you, that is The generator has a single turn coil. What is the meaning of single turn coil? Understand carefully. This is single turn. 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 He is saying that, sir, the average voltage generated between one commutator segment is 15 volts and it is a single turn coil. So actually he is giving me EMF per turn. Yes or no? Are you able to observe this? EMF per turn is 15 volt. So can you tell me what is going to be generated EMF? The EMF for one parallel path. Because parallel path, how many you connect, it will always remain same in terms of voltage. So the EMF in one parallel path will be EMF per turn multiplied by number of turns in one parallel path. Hello? Number of turns in one parallel path. Total number of turns, Z by 2, divided by A, that will be the number of turns in one parallel path. So just put this value. So it will be 15 Z by 2 divided by A. This is IA. And it will be 1200 10 to the power 3. Is it clear? Now these two equations, equation number 1 and equation number 2, you have to solve and you can get the number of poles. Is it clear, everybody? Are you getting this? Everybody tell me yes or no. So I'm not 100% sure, but as per my memory, I think you must be getting number of poles as 10. Number of poles as 10. Interesting question, yes or no? See the next question. Very interesting question now. Even though it is a very straight question, but it's a good question. Mr. Naik Creations is saying no. So instead of saying that no, we are not getting, you better tell me what is your doubt. Why do you divide it by A? What I have divided by A? This one? Yes or no? Now listen very carefully. Very interesting thing asking. This is your DC machine. Let us go inside the armature. Let us go inside the armature. Be very careful. Lot of sparking because of commutation. We have to be quite careful. Let us go inside the armature. Inside the armature, your machine looks like this, dear. Yes or no? Number of parallel paths 1, 2, 3 up to A. Yes or no? So what is the EMF? EMF in one parallel path? One parallel path. How many number of turns per parallel path? This is what I want. Because I know the EMF in one turn. So if I have the number of turns per parallel path, just multiply it, you will get the EMF. Number of turns, how you are getting? Z by 2. Total number of conductors divided by 2 because 2 conductors give you 1 turn. 2 conductors give you 1 turn. So Z conductors give you Z by 2 turns. Per parallel path. So divide it by total number of parallel path. Hello. What is total EMF? EMF per turn multiplied by number of turns per parallel path. Z by 2 divided by A. Mr. Murli, are you getting this now? Ram ji se Ram Ram kahiyo. Is it clear, everybody? See the next question. A 250 volt series motor draws an armature current of 85 amperes at a load torque of 314 Newton meter. The speed is given as 600 RPM. Armature resistance and series field resistance is mentioned. Rotational losses are negligible and iron parts are unsaturated. Why they are writing unsaturated? Because if it is saturated, if I am saying if it is not for this question, but if it is saturated, if saturation is there, then flux becomes constant. If unsaturated, dear, it is a series motor. Series motor flux is directly proportional to armature current. So whenever you are solving question for series motor, be very clear to check whether it is saturation or unsaturation. If it is saturation, then flux becomes constant. Now, he is asking find the speed when the torque requirement at the shaft is reduced to 20 Newton meter. How we are defining the torque? Torque for any DC motor we are defining as K phi Ia. K is a constant. What is the value of K? It is Pz upon 2 pi A. So it is a constant because number of poles, number of conductors, number of parallel path, all are constant. But the flux for a series motor is directly proportional to the armature current. So can I write that the torque is directly proportional to the square of the armature current? So can I write T2 by T1 is equal to Ia2 by Ia1 square? Yes. What is the torque? In the second case, the torque is 20 Newton meter. In the first case, the torque is 314. Initially, what is the armature current? Armature current in the first case, it is 85 amperes. Good evening, Mr. Ashok. How are you? Welcome to the session. So it was, armature current was 85 amperes. Put it 85 amperes and tell me what is the value of Ia2 you are getting. You all must be calculating right now. Okay, whenever you get the opportunity, don't forget to practice the calculation because calculation is going to be the only lagging in your gate performance now because you cannot change anything. So one is saying 6.7, one is saying 21.45. So that is the best difference in the answer I can get. Don't use Chinese calculator. Okay, use made in India calculators. Tell me what is the Ia2 you are getting. And whenever you have to relate the speed for DC motor, EMF is K phi omega. Now phi, listen very carefully. Phi is directly proportional to armature current and omega is speed. Yes or no? So can you write E2 upon E1 as Ia2 N2 upon Ia1 N1? It's okay, it's okay. Now what is E2 and E1? What is E2 and E1? This is your series motor. आर्मेचर गलत हो गया, फिर से बनाना पड़ेगा. आर्मेचर सीरीज फील्ड टर्मिनल वोल्टेज लाइन करंट सीरीज फील्ड करंट सीरीज फील्ड रेजिस्टेंस armature resistance back EMF and this is armature current. So can you tell me what is the back EMF for both the cases? You know armature resistance, you know series field resistance. Terminal voltage is same, it is not changing. Armature current you know. So one case E1 you will be getting as V minus IA1 RA plus RSE. Terminal voltage is 250. Terminal voltage is 250. First case armature current 85. Armature resistance and series field resistance 0.12, 0.09, 0.12, 0.09, 0.12, 0.09. Just calculate E1. Can you calculate E2? E2 is V minus IA2 RA plus RSE. Terminal voltage same. Armature current in the second case, you have found 21.45. Please cross check this value. 21.45. 21.45. 0.12 plus 0.09. Just check what is the value you are getting for E2. Even Mr. Ram is getting 232.15. E2. Anybody calculated E2 without using the Chinese calculators? 245.49. मजा आ गया. मजा आ गया. You know E2, you know E1, you know IA2, you know IA1, you know N1, you don't know N2. Can you calculate N2? Can you calculate N2 now? I know you can calculate, but tell me the answer. हो जाएगा. हो तो जाएगा दोस्त, जल्दी करो. Tell me fast. Let me connect the charger and you tell me the answer. Tell me the answer. N1 you don't know. Let me tell you what is N1. N1 is 600 RPM. Calculate fast. Without calculation, we cannot move. 2514.5. Only one share is there. और भी कोई शेयर है सेशन में कि सब बकरी है? You want to become a goat or a lion? If you want to become a lion, you should always be like this. Like this, you should be always be taking the position. Always on toes. And what the goat does? Like this. Anytime lion can eat. So don't be a goat, be a lion. So friends, please cross check. Students are getting it. Yes, greatest of all time. 2514.5 RPM. See the next question first. A 220 volt DC shunt motor is operating at a speed of 1440 RPM. The armature resistance is 1 ohms. Armature current is 10 ampere. If the excitation of the machine is reduced by 10%, it means phi2 becomes 0.951. 10% reduced, what is remaining? 90%. The extra resistance to be put in the armature circuit to maintain the same speed and same torque. Forget about same speed and same torque. If you are putting an extra resistance, it is going to look something like this. You are putting extra resistance in the armature circuit, so it looks like this. This is armature resistance. This is external resistance you have kept. This is the shunt field for your shunt motor. And this is the terminal This is the terminal voltage. This is the line current taken from the supply. This line current gives you the armature current and the shunt field current. Shunt field resistance like this. And this is your back EMF. You tell me one thing. In the second case, you have put the external resistance. Can you write the KVL equation for the second case? Can you write the KVL equation for the second case? Terminal voltage is EB2 plus IA2. It is RA plus R external. From there, if you know V, if you know EB2, if you know IA2, if you know IA, can you find the R external? Yes. So what is your next step? Terminal voltage you know, 220 volts. Terminal voltage you know, 220 volts. What is EB2? You don't know what is back EMF. So first you have to find the back EMF. How you are writing back EMF? Back EMF is K phi omega. K phi omega. Now you can write back EMF as directly proportional to flux and what is the speed? N. He is saying, sir, speed is constant. Speed and torque both are constant. When speed is constant, can I write the back EMF directly proportional to phi? So can I write back EMF second case, back EMF first case as phi 2 upon phi 1? Phi 2 upon phi 1 is 0.9. So can I write back EMF in the second case as 0.9 back EMF in the first case? Yes, Vishwanath, please wait. How you are writing the back EMF in the first case? In the first case, there is no external resistance. Terminal voltage 220. Armature current given? Yes. Armature current is 10 amperes. 10 amperes. Armature resistance 1. Anything else? No. So 220 minus 10, 210 volts. Can you tell me the back EMF in the second case? Yes, 0.9 multiplied by 210. Yes, Shivam, wait. I cannot be at your speed. You are going to become rank 1. Okay, I am beyond that. So just calculate it. 189 volts. So now you got the back EMF also. What is the current? What is the current in the second case? Now you have to apply the torque. Torque is same both the cases. And torque is directly proportional to flux and the armature current. So can I write phi 2 IA2 is equal to phi 1 IA1? Yes. So can I write IA2 is phi 1 upon phi 2? This is IA1. Yes. What is IA1? 10 ampere. What is phi 2 upon phi 1? 0.9. Just calculate it. 100 upon 9. 100 upon 9. Calculate what is the value you are getting. So that will be your IA2. So my friend, you got everything. You got IA2, you got RA, you got EB2. Can you tell me what is R external? अरे यार तुम मुझे क्या पार्टी दोगे? पेड़ कभी अपने फल खुद नहीं खाता, दरिया अपना पानी कभी खुद नहीं पीता. समझे मेरे भाई? मुझे पार्टी मत देना. अगर कुछ करना है, अच्छी रैंक आ जाए, अपने माँ बाप के पैर छू लेना मेरी तरफ से. जो कुछ हो, जो कुछ बनोगे और जो कुछ करोगे जिंदगी में, बस माँ बाप की वजह से करोगे. So everybody is getting that? Armature resistance is 1 ohms, na? 1 ohms. 1 ohm. So I don't know how much you are getting. A, are you getting A? 1.79 because Shubham is getting 1.79. Perfect. Everybody is getting 1.79. Perfect. Great. Now see easy questions because now power system starts. 15 horsepower, 440 volts, three-phase motor is operating at full load, 85% efficiency. Now, who was asking about rated and full load? Just see here. 0.9 power factor lagging the real and reactive power drawn by the motor. Now, understand. 15 horsepower is the output of the motor, shaft output power of the motor. So this is output given in mechanical terms. Change it to the electrical terms. 746 watts multiply. You get the output power. Efficiency is given. Efficiency is what? Output power upon input power. So basically you can find the real power taken by the motor as input power. Yes, Shubham. Vishwanathan Murli. Same torque means. Wait, wait, wait. Wait. Just give me one moment. My daughter is here. Please go. Just give me one moment, okay? So sorry for the disruption. Yes, Vishwanath, what is your doubt? Previous question. Okay, let me go to the previous question. Let me answer the doubt for Vishwanath. He's saying same speed and same torque. So you don't need to calculate the torque. You have to just relate the torque for the two cases as same torque so that you can get the armature current. Are you getting that? Mr. Vishwanath, are you getting now? I think you're mixing two questions. Same torque. Baba. Same torque. I think it's okay. Okay. Yes. So you can get the input power, input real power taken by the motor. So output power is 15,746 divided by efficiency, that is 0.85. Once you get the real power, variously you can calculate the reactive power taken by the motor. It is nothing but P input 10 phi. So 10 phi, what is phi? Phi is cos inverse 0.9. Get all the values. I think B must be the answer. Everybody is getting B, easy question. In GATE also you will be getting easy questions. Most of the questions are going to be easy. 15-20% questions will be difficult. So don't fear. Go with full confidence. How many of you have seen that Bahubali movie? Have you seen Bahubali Part 1? You remember the first villain in the movie? That tribal who says like this, something like that. I don't know the exact language. So they have a large army. But the Bahubali side, people were less. But how he motivated that whenever you fight, you always fight to win. That's it. 60 to 70% of the paper is going to be easy for you. Just 20-30% is difficult. That difficult you keep for others. You focus on 60-70%. Okay. I hope it's okay. So you are from Andhra, big fan of Bahubali. I have also been in Hyderabad. See the next question. Bundled conductors, hypothetical two subconductor system is to be designed as four subconductor bundles as shown in the figure. Nothing, just equate the current. I1, I1, I2, I2. Because the radius is same, so I am saying this. जिंदगी में रोज रोज जीतना होता है तुम तो शायर हो भाई यू आर खिलाड़ी कुमार so radius same so I am taking I1 I1 I2 I2 I3 I3 now equate the currents so 2 I1 current must be same na because it is parallel circuit these two are in parallel these four are in parallel so 2 I1 is should be equal to 2 I2 plus 2 I3 so you can write I1 is equal to I2 plus I3 now you know for transmission line current is defined as current density multiplied by cross-sectional area, but current density is constant for transmission line because load tappings are not allowed. Generally, we are not connecting the load. Okay? Yes, you are right, Ram. So, current is directly proportional to the area. So, you can write A1 is equal to A2 plus A3. Because it is circular and cylindrical, so area is going to be pi R1 square, pi R2 square, pi R3 square. So R3 becomes, pi will be cancelled, R1 square minus R2 square. Just put the values, what is R1? It becomes 4. R2 square becomes 1, becomes under root 3, that is 1.732. Yes, Ram, you're right. Great input. That circle area is pi R square. So it is 1.732. See the next question. See the next question. A 200-kilometer medium transmission line is operating at 50 Hertz. It has the following line parameters. Assume the sending end and receiving end capacity. Okay. So you can say it is a multiple select question. Assume that it is a multiple select question. He is asking both about the sending end and receiving end capacitor model. When it is sending end capacitor model, it is something like this. Sending end capacitor model is like this. This is sending end. Yes or no? Connect the total capacitance at the sending end. So this is your Y, this is your Z. So these are cascaded form of two networks. Cascaded form of two networks. Whenever you have whether short, medium or long transmission line, the first thing you have to do is find the ABCD parameters. If you have ABCD parameters, you can solve anything for the transmission line irrespective of whether it is a short, medium or long transmission line. So cascaded network, you can find the ABCD parameters as for shunt admittance, it is 1, 0, Y1. For series impedance, it is 1, Z, 0, 1. Just multiply. So it is 1 into 1 plus 0 into 0, so 1. 1 into Z plus 0 into 1, so it is Z. Y into 1 plus 1 into 0, so Y. Y into Z plus 1 into 1, so 1 plus YZ. We are focusing on A parameter. In the question, he is asking A parameter, na? So as per the sending end capacitor model, A is 1. Hello. As per the sending end capacitor model, magnitude of A is 1. Let us see the receiving end capacitor model. Receiving end capacitor model, something like this. This is Z, this is Y. Again, cascaded form. Yes, you are super talented, Ram. Perfect. So, what is going to be ABCD parameters? A, B, C, D, E, A, B, C, D. So, for Z, it is 1, Z, 0, 1. multiply by, it is 1 0 by 1. Do the multiplication on your own, very difficult. It is 1 plus yz, z y 1. For receiving and capacitor model, magnitude of A becomes magnitude of 1 plus yz. You must be knowing this. I have to be energetic now, then only you can be energetic. Anyways, always be happy, then only you can give your 100% of the performance. So now, in order to find this 1 plus yz, what is z? It is r plus j omega L and multiplied by the length. Yes or no? This will be ohms. What is y? It is j omega c, because g is not mentioned, multiplied by L, and it becomes Siemens or mho. It's okay, don't get worried. Okay. So if you put the values, you can calculate it, but I think you must be getting it less than 1. Now, why I'm saying you will be getting less than 1, there is one candidate in the comment section also, he is saying Ram, that it will be less than 1. So I don't know whether he is confident or not, but without solving, I can tell you that 100% confidence it is going to be less than 1. Why? I will tell you the reason. In the sending end capacitor model, listen very carefully. Even in this question, you don't need to do this much calculation. Yes, you got the answer. Ferranti effect. You have to use the concept of Ferranti effect here. In the sending end capacitor model, all the charging current is bypassed. It is not passing through the inductive element of the line. So there is no Ferranti effect. There is no Ferranti effect. Are you getting this? So you are getting 1 here. Now, so receiving end capacitor model, charging current is passing through the inductive element of the line, and it is not just passing. The line current is dominantly capacitive. First condition. Second condition, all the charging current is passing through all the inductive element of the line. So it is the extreme case of Ferranti effect. So extreme case of Ferranti effect means mod Vs is less than mod Vr. So if you write it in terms of ABCD parameters, it is AVR plus VIR, it is 0. And Vs less than Vr means mod A has to be less than 1. So directly you can write it. So for the MSQ question, you will be getting A also as the correct answer. Everybody is getting now. Everybody is getting now. See the next question. A 220 kilovolt 50 hertz single circuit line is 200 kilometers long. So length of the transmission line is mentioned as 200 kilometers. The line parameters are mentioned like this. The line supplies a load of 60 megawatt at 220 kilovolt, 0.8 power factor lagging. So can you tell me what is the receiving end current? It is 60 megawatt. It is 220 10 to the power 3 and the power factor is 0.8. So this will be your receiving end current. You have to write the angle also. So because it is a lagging 0.8 power factor lagging, so minus cos inverse 0.8. Minus cos inverse 0.8. You got the receiving end current completely. What is the receiving end voltage? Receiving end voltage is this. That is 220 kilovolt angle 0 degree. Take it as a reference. You got the receiving end voltage. You got the receiving end current. He is asking the voltage regulation for nominal pi representation. Nominal pi representation is something like this. This is Z, this is Y by 2, this is Y by 2. If you find the ABCD parameter, it is going to be 1 plus YZ by 2 Now, which is not divided, z is not divided here. So, z coming here and it is y1 plus yz by 4. And this is 1 plus yz by 2. So, I am basically interested in A parameter because I have to write the voltage regulation. And you know that voltage regulation is, the general expression is mod Vs upon mod A minus full load receiving end voltage divided by VR multiplied by 100. Is it clear? So how you can get the sending end voltage? Sending end voltage you can get as AVR plus BIR. Put the value of I, put the value of VR, get the value of A and B. You have to solve it. It's a lengthy question. Okay, just for the sake of understanding purpose, I have taken this question, but a small part of this question may be asked in GATE examination. When it comes in the GATE examination, it is going to be little easy in terms of calculation because they know the bandwidth. They know that within 3 minutes you have to solve one question approximately. So you got the sending end voltage, you got the A parameter, you know the receiving end voltage, you can calculate the voltage regulation. Yes or no? Can you do it as your homework? Tonight itself before you go to sleep, you have to do it. Okay. See the next question. A three-phase induction motor of 500 horsepower has a 90% efficiency at 0.8 power factor lagging. Again, the output of the motor is given, efficiency given. It means basically you have to find the input power. Whenever output is given, efficiency is given, it means he wants you to calculate the input. Yes or no? 0.8 power factor is mentioned. It means you can calculate Q input also. For the induction motor, you can calculate P input and Q input. Now he's saying there is a loaded 120 kilowatt synchronous motor so that the overall power factor becomes unity. Find the power factor of the synchronous motor. Now the most important part is power factor becomes unity. Which power factor becomes unity? The system power factor becomes unity. What is the significance of power factor becomes unity? It means phi becomes 0. When phi becomes 0, if this is real power, this is reactive power, and this is angle phi, phi will become 0 when Q is 0. So the reactive power which is coming from the supply side must be 0, then only you will have a system power factor as unity. It means whatever reactive power is supplied by this synchronous motor, that is going to the induction motor. Hello? Yes or no? So can you tell me what is the output? Output of the induction motor, I am saying. Sorry. For the induction motor, what is the output? Can you tell me? It is mentioned. Real power output. 500 horsepower. So 500 multiplied by 746 watts. Can you tell me the input power for the induction motor? This is the input power taken by the motor from the supply. So this is going to be output upon efficiency. This is output. What is the efficiency? 90% efficiency. So 0.9. Just calculate it. Can you tell me the reactive power taken by the motor? That is Q induction motor. Yes, it will be P induction motor, 10 phi induction motor. P induction motor you have calculated. What is phi induction motor? The power factor angle of the induction motor. So this is 0.8. So it becomes cos inverse 0.8. Approximately 36.86 degrees you will be getting. Yes, Shubham. So if you calculate Q induction motor, you must be getting somewhere around 310.83 kVAR as per my memory. You can cross check it. Now, he's asking the power factor of the synchronous motor. Now, synchronous motor is taking real power. It is actually a synchronous phase modifier, the most practical device for power factor correction. It is taking real power from the system and at the same time it is supplying the reactive power. How much real power it is taking for the synchronous motor? P synchronous motor is 120 kilowatt. What is Q synchronous motor? That is the reactive power supplied to the induction motor. This is 110.83 kVAR. Can you tell me the power factor? This is P, this is Q, and this is SSM. This is phi SM. What is cos phi SM? That is the power factor of the synchronous motor. It is PSM upon under root PSM square plus QSM square. Let's find it. You must be getting somewhere around 0.36. But the question is not over. You have to find lagging or leading. Very interesting. Very interesting. For synchronous motor, I am giving you a Guru Mantra. Just give me one moment. Connect the charger. I hope now it is okay. So what I was saying, yes, a Guru Mantra for synchronous motor. Synchronous motor is supplying reactive power. Which type of reactive power? Lagging reactive power. What is the nature of motor? To supply or to absorb? The nature of synchronous motor is to absorb power. It is supplying lagging reactive power. It means it is taking leading reactive power. Are you getting, Vishwanath? I am telling you something beyond that. How to find it? Go by the very basics. So the basic nature of motor is to absorb power, and it is absorbing leading power. It means what is the operating power factor? Leading. What is the correct answer? 0.36 leading. B. See the next question. A three-phase transmission line has a series impedance of 5 plus J20. It means resistance is also there. No more you can use the shortcut. You have to go with the conventional way. It delivers a load of 30 megawatt at 0.8 power factor lagging at 33 kilovolts. Both the sending end and receiving end voltage are at the same voltage. Find the reactive power supplied by the synchronous condenser. Synchronous condenser is supplying some reactive power. Yes or no? Yes? Now just let me first write the power balance. Power balance at the load side. Now, synchronous condenser is an overexcited synchronous motor which supplies lagging reactive power to the system without any exchange of real power. If there is no exchange of real power, so whatever real power is coming from the supply side up to the receiving end, that is supplied, that is given to the load. So can I write the real power received is equal to P load? 100% confidence? Yes. Previous question, load power. Load is three-phase induction motor, dear, na? Are you getting this? Load power induction motor you are calculating, na? It's not given directly. Output is given 500 horsepower. Now, coming to this. Now, let us see the power balance for the reactive power. QR is coming from here. QC is coming from here, and both is absorbed by the load. So, can I write QR plus QC is equal to Q load? Can I write this or not? Yes. Yes? Okay. Now, for the real power received, do you have any question? Yes. Mod Vs, mod Vr, mod B cos beta minus del minus mod A mod B mod Vr square cos beta minus alpha. VSVR you know. VSVR you know. 33 kilovolts. ABCD you have to find. ABCD parameters. It is going to be 1Z01. Okay. It is mentioned 5 plus J20. Z is 5 plus J20. So if Z is 5 plus J20, magnitude A becomes 1, alpha becomes 0, magnitude B becomes magnitude Z, that is under root 5 square plus 20 square. And what is beta? Beta is theta, that is tan inverse 20 upon 5. Just calculate these two values and put it in the equation. So my friend, you have all the values here. And why I'm writing it? Because we have to find the del value. If you know the del value, then only you can find the reactive power received. This is given as 30 megawatt. In the question itself, it is mentioned. Yes, 30 megawatt. Perfect, Shubham. This is 33, 33. B is mod Z. Beta, you know, is theta. Del, you don't know. Mod A is 1. Mod B, mod Z. VR, you know. Beta, you know, alpha 0. So this equation, you can calculate what is del. I don't have a reference for this. You have to solve it. Shubham is solving, only one candidate. So please do this as your homework. Are you getting that? So you have found what is QR. But he is not asking this. He is asking, listen very carefully, the reactive power supplied by the synchronous condenser. So that becomes Q load minus QR. Q load minus QR. Do you have any idea about the Q load? Yes. What is PR? 30 megawatt. That is nothing but P load. Do you have the load power factor? Yes. Load power factor is 0.8. Load power factor is 0.8. So can you tell me, dear, what is Q load? Yes, it is sir P load tan phi. What is P load? 30 megawatt. Tan. What is phi? Cos inverse 0.8. Can you calculate this? I'm coming to that, Shubham. Listen carefully. Listen carefully. Whenever you are writing the power equation, be very careful. Shubham is asking something really good. Whenever you are writing the power equation, be very careful. If sending end and receiving end voltage you are writing in line voltages, then directly you are getting three phase powers. Hello? Hello? If you are writing VSVR in terms of phase voltages, then you are getting single phase power. Now here, because Z is mentioned as per phase, this Z is per phase. So always you have to, generally ABCD parameters you have to use with the per phase concept only. For the shortcut only, if you put the line voltages directly, you will get the three phase. But here you have to change VSVR as 33 upon under root 3. That is the great input by Mr. Shubham. Is it clear, everybody? Okay. So just solve this. I think you will be getting the answer as per my memory. You must be getting it 42.74 MVAR. Just calculate it as your homework. And tonight, before you go to sleep, you have to complete all these questions. Never leave anything in between. See the next question. A 5 kilometer 11 kilovolt 50 hertz 3 core 3 phase lead sheathed cable is experimented with one of the core connected to the sheath, and the capacitance is measured between the remaining two cores is 0.75 microfarad. What is the capacitance per phase? How you define the capacitance per phase of the three phase core cable? It is CS plus 3cc, if you remember it. Wait, Shubham. Okay, so he's asking. So one thing you do now, instead of here dividing by root 3, directly you put 33 kilovolts. Directly you will be getting three-phase power. Okay. Just for the sake of understanding, you take this, otherwise just put directly 33 kilovolts, so no need to change it later on. Shubham, I think you're getting the point now. And others also please understand. Generally, ABCD parameters you have to write with per phase concept only. But you can use this short because at the end of the day, again, you have to multiply it by 3 if you do the per phase analysis. No? So use this advantage that when you write the line voltages in the power equation, directly you get the three-phase power. I hope it's okay. So go to this underground cable question, what he's saying. Yes, that is why I'm saying PR is three-phase. No? Yes. So it will be a lot of confusion if you go by that. So better use the line voltages. Everybody's okay with that. So there is a three-phase core cable, ABC. So this is CS, CS, CS. This is CC, 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 and this is grounded. In the experiment, he is saying this is A, this is B, this is C. He is saying suppose one of the core is connected to the sheath. Suppose C is connected to the sheath. So connected means short circuited, so capacitance gone. CS is gone here. And the capacitance is measured between the remaining two cores is suppose C3. Because there is a standard experiment, third experiment, so I'm writing C3, don't get confused. Now, see it very carefully. What is C3? What is the first thing you are going to observe here? This CC, yes or no? Then you will see two parallel paths because I can remove this. Yes or no? And I'm going to make it separate. Same thing, either you do it like that or like this, it is same thing. So here CC and CS coming in parallel, CC and CS coming in parallel, and these two connected in series. So the situation is something like this. It is CC plus CS. This is also CC plus CS. This is what you will observe as C3. Yes or no? So can you tell me what is C3? C3 becomes CC plus CS by 2. Simplify this, it becomes 3CC plus CS by 2. What is this 3CC plus CS? This is nothing but capacitance per phase, and this is mentioned as 0.75. 0.75. So what is going to be capacitance per phase? It is 1.5 microfarad. Yes or no? Shubham, if you remember the formulas, then sometimes you can do the mistake. Okay? Better focus on the concepts. Your concepts are good. Do not over rely on the formulas. Size of the Jacobian matrix he is asking. So you have to tell me number of PV buses, number of PQ buses. Power system contains 300 buses. Okay. So total bus 300. Out of which 20 buses are generator buses, 25 buses with reactive power support buses, and 15 buses with shunt capacitor. Now shunt capacitor buses, even though these are PV buses, they will be treated as PQ buses. Why? Because if you want to help your friend economically, so can you help him without knowing what is the status of his finances? No. He may require 10 lakh rupees and you may be having 10,000 rupees in your account and you are saying भाई जिंदा है. But भाई जिंदा होके करेगा क्या? उसको चाहिए 10 lakh. He needs 10 lakh and you have 10,000 in the account. Can you help him? No. You can only help him if you know the finances. So you can only provide the shunt capacitor compensation if you know what is the current status in terms of reactive power. That is the reason buses having the shunt capacitor being treated as PQ buses. So total 20 and 25 buses are going to be generator buses. 45. Out of this, one will be slack bus. What is remaining? 44 buses will be PV buses. What about PQ buses? So out of this total buses, 300 minus total generator buses 45 minus 45 will be your PQ buses. Can you tell me what is the number of PQ buses? 10 में से 5 गए 5, 9 में से 4 गए 5, 2, 255, 255. Number of PV buses, total generator buses 45 minus 1. So these are 44 buses. What is L? Number of P specified. So number of P specified, P is specified at both PQ and PV buses. So this is 255 plus 44. So it becomes 5 no 299. What is M? Number of Q is specified. Q is specified only on the PQ bus. So it is number of PQ buses. That is 255. So what is the size of Jacobian matrix? It is L plus M cross L plus M. What is L plus M? 9 5 14 के 4 हासिल लगे 1 9 1 10 5 15 के 5 हासिल लगे 1 2 1 3 2 5 5 5 4. So it is 5 5 4 cross 5 5 4. Everybody is getting that? Next question. A synchronous motor is receiving 50% of the power. Okay. Suppose it is 0.5 per unit. It is capable of receiving from an infinite bus if the load on the motor is suddenly reduced to 80% of the previous value. 80% of the previous value is 0.5, 8 पंजे 40, so it becomes 0.4. Yes or no? So it becomes 0.4. He is asking what is the swing of the motor in the new equilibrium position. You have to apply the equal area criterion here. So it is something like this. So please forgive me for my beautiful drawing skills. Real power del. This is power angle variation sinusoidal. Okay. Suppose this is P is equal to P max sin del. So what is happening here? Let us see. Everything was good when it was 0.5. Everything was good when it was 0.5. This was suppose del naught. Now suddenly from 0.5 the power is reduced to 0.4. 0.4. So it is not going to go from this point, operating point A, to new operating point B directly. It will go from A to B and beyond B also it will go. Yes or no? Beyond B also it will go. Because there will be the inertia of the motor. So suppose it is going somewhere up to here. This is del 1 new operating condition. This is del 2. So basically you have to find the positive area and negative area. Always remember the concept of sky and ground. Always remember the concept of sky and ground. What is sky? The power. What is ground? The characteristic. P max sin del. Okay, are you getting that? Now, area A1 and A2 you have to equate as per the equal area criterion. Suppose A1 is the accelerating area. Accelerating area is always between the sky and the ground. You can say this area. So this is going to be your accelerating area A1. What is decelerating area? Ground and sky. This is A2. Can you write A1 and A2? Yes. What is A1? Listen very carefully. A1 is del 1 to del naught. It is del 1 to del naught, del 1 to del naught, and P max sin del minus 0.4. It is Pm sin del minus 0.4, and this is d del. What is A2? A2 is del 2 to del 1, del 2 to del 1, and it is 0.4 minus Pm sin del, it is d del. Now you can relate some del naught also here, because del naught power is 0.5. So you can write 0.5 as Pm sin del naught. Pm is mentioned here. So Pm you can take as 1 per unit, okay? Just take it as 1 per unit. I think there is some misprint in the question. It should be 50% of the maximum power. That is why I'm taking Pm as 1 per unit. So take Pm as 1. So what is del naught? So del naught becomes 30 degree. Yes or no? Similarly, you can calculate del 1 also. Yes or no? Can you calculate del 1? Yes, it is 0.4. Pm is 1. It is sin del 1. So what is del 1? You can calculate. Now the only thing you have to calculate here is, okay, Shiva, you have to calculate the swing. What is the swing? Swing means how much total change in del is happening here. So you have to follow this. You have to find del naught minus del 2. This is what you have to find here. Total change in del is the swing. Is it clear, everybody? Is it clear? Okay. See the next question. In a system, there are two generators operating in parallel. One generator operating in parallel means they are swinging coherently. They are swinging coherently. Swinging coherently means what? Del 1, del 2 same as del. जिएंगे साथ साथ मरेंगे साथ साथ. Swim together, sing together. In that case, angular momentum equivalent, angular momentum is given as m1 plus m2. You know m is gh upon pi f. Pi f is a constant, so you can write g equivalent, h equivalent as g1 h1 plus g2 h2. So g equivalent you can write g1 h1 plus g2 h2 divided by, sorry, he's asking h equivalent. So it is h equivalent and this is g equivalent. Just put the values. So it is 6 megajoule per MVA. Okay. 250 plus 150 into 4 divided by G equivalent is 100. Just solve this. You will be getting the answer. Is it clear? Now this is the case when it is swinging coherently. If it is not swinging coherently, suppose you get a question when generators are not swinging coherently, then what is the relation? Then M equivalent is, this is how you can correlate 1 upon M equivalent is 1 upon m1 plus 1 upon m2. Is it clear, everybody? So this is all from my side for today. I hope you enjoyed the session by me and Ashu Sir. We tried our best to give you some best questions and revision just before your GATE examination. So all my best wishes. Once again, a very happy Republic Day to all of you. All my best wishes are always with you. You fly with bright colors this GATE examination. All my best wishes. But before I leave, wait, Shubham, I will come to that. Listen. I will discuss, don't worry. This is about the GATE and Engineering Services test series, where you get the unlimited access to the full-length mock subject test. The link is given in the description that you can follow. The important features of this test series is you will be getting 60 plus tests covering GATE and ECE, detailed mock analysis, virtual scientific calculator, 4,000 plus practice questions, all India open mocks curated by GATE experts. But before I conclude, let me answer Mr. Shubham. Wait, Vishwanathan, I will answer you. Shubham, you are asking full load current. Okay. Suppose you're talking about full load current. What is the meaning of full load current? Full load current is nothing but the rated current. Full load current is nothing but the rated current. When you are saying short circuit current, what is the meaning of short circuit current? Suppose you are talking about a generator. Suppose you are talking about a generator. Now you are saying generator terminal short circuit. I'm just giving you one simple example. So this is how you find the short circuit current. Okay. Full load current, rated current, short circuit current. Yes, this is not your doubt. This is Shubham's doubt. What is the difference means what? Full load current means when the rated load is connected. So you get the rated current. Short circuit current, see, short circuit current, open circuit current, these are basically for testing purposes. Okay. No, I'm not saying they are same. I'm telling you what is the difference. Short circuit current means the terminals you have short circuited. If you talk about the transformer, then one side is short circuited. Then what current you are getting from the supply, that is short circuit current, rated short circuit current. रेटेड लोड होता क्या है? रेटेड लोड ये होता है भैया, जैसे आपने बनाया एक जनरेटर, आपने एक जनरेटर बनाया, बना दिया जनरेटर, अब आपने इस जनरेटर की करी टेस्टिंग. क्यों टेस्टिंग करी? क्योंकि आप ये जानना चाह रहे थे कि इस जनरेटर से आपको बेस्ट परफॉर्मेंस कब मिलेगी, इसकी परफॉर्मेंस, इसकी इफिशिएंसी बेस्ट कब होगी. तो आपने एक रेटेड लोड डिफाइन कर दिया कि भाई ये लोड अगर लगाओगे तो सब कुछ आपकी जनरेटर की जिंदगी में अच्छा चलेगा. बात समझ में आ रही? ये है रेटेड लोड. How we say what is the rated load for a generator? To get the best performance out of the generator. How we say what is the rated load for a transformer? So that you get the best performance of the transformer. When you say any extreme condition like open circuit, short circuit, so that we are using for the testing purpose. For example, you do the open circuit test, you do the short circuit test. समझ में आ रहा है शुभम जी आपको? मतलब शॉर्ट सर्किट लोड तो वर्स्ट केस हुआ ना, एज द करंट विल बी मैक्सिमम. यस, यू कैन से लाइक दैट. You can say like that. No. Just now I told you, rated means you get the best performance out of your generator, machine, or device, whatever you are talking about. Short circuit means this is the extreme condition which you use as an experiment to find the unknowns in terms of the circuit parameter. You are mixing things, dear. And one thing more, short circuit current can also be rated. Rated short circuit current. Yes or no? You are mixing things basically. You can connect me separately on my personal Telegram channel. You can ping me. We can have more discussion on this. So Vishwanathan, I don't know what you were asking. Power factor wala. So let me just talk to now Vishwanathan. Shivam, we can separately discuss now. Okay. Vishwanathan Murli is asking, sir, capacitor must deliver some reactive power na to load that is equal to P input 10 phi, then it should absorb power. So what is power factor we need to equate? You are asking about this question. Just let me check. Please tell me if I am wrong. We're talking about synchronous motor. Yeah, definitely, Shivam, we will discuss. I will try my best to satisfy your doubt. So this is the question you are asking, or this question? Sorry, this question. Question number 26 you are asking, Vishwanathan? Yes, Shivam, we'll discuss, don't worry. Okay. So you are saying how power factor becomes unity. Now listen very carefully. When you say the system power factor becomes unity, it means what? It means the reactive power burden from the supply side is zero. So whatever reactive power is supplied by this synchronous motor, that is going to the induction motor. Induction motor always absorbs that lagging reactive power. Synchronous phase modifier or the overexcited synchronous motor is going to supply the lagging reactive power to the system. So whatever reactive power is supplied by the synchronous motor, that is delivered to the induction motor. So the reactive power coming from the supply side is zero. That is how we are construing that the supply, or you can say the system power factor, is unity. Now, what is your doubt in this? It's crystal clear, I think. Tell me fast, Vishwanathan. Synchronous motor power factor. Synchronous motor power factor. That is what we have found, na? You know the real power. Understand this. Understand this. Understand this. This is the case. This is induction motor, three-phase induction motor. This is your synchronous phase modifier. Synchronous phase modifier is having some real load connected to it. So it is taking P synchronous motor power and it is supplying Q synchronous motor power. You know P and Q, you can find it. Thank you everybody. So this is all from my side, friends. Thank you so much for joining me live in the discussion. It was a great time talking to you. All my best wishes for all of you. Thank you so much. Stay connected to BYJU'S Exam Prep and do not miss any of the session. Vishwanathan is saying again something. Please let me answer him. Listen, listen. Listen. He is asking the power factor of the synchronous motor. That is the synchronous phase modifier. He's not asking the power factor of the induction motor. The power factor of the induction motor is already there. You can never ever change the power factor of the motor. Once you design it, it's fixed. You can't change it. You can only improve the system power factor here. Okay, Vishwanathan, you also please come to the Telegram channel because serious cases has to be dealt in ICU. So you have to come to my Telegram channel for personal discussion now. It's okay? Yes, Shubham. Thank you. Thank you, everybody. Take care now. So thank you so much, everybody. Any doubt, most welcome. You can tell me in the comment section or you can reach out to me on my personal Telegram channel. Thank you so much. Take care. Thank you, everybody.